Hello and good afternoon, everyone, and a very good afternoon to my dear lovely students. I welcome you all to this wonderful channel by Unacademy NEET English, and I believe you all are doing good and having a great time. Before we move ahead, let me know in the chats if I am perfectly audible and visible to all of you. Let me know in the chats quickly. Let me know in the chats quickly if I am perfectly audible and visible to all of you. Let me know in the chats quick. Okay, all right. I believe you all are doing good and you are super excited for today's session. And if you are super excited for today's session, then smash the like button right now and do share the stream with your friends, my dear lovely students. Today, we will be solving JEE Mains Organic Chemistry PYQs, and it will take your NEET preparation to the next level. Our target is to solve as many questions as possible with proper, what we call understanding. And my dear lovely students, rather than rushing through them, because our priority is basically what we call quality learning. So keep your notebooks ready and try to simply attempt every question, my dear lovely students, and let's begin without wasting much time. So are you ready so that we will start today's session? Are you ready, guys? Come on, let me know in the chats quick. Are you ready for today's session? Come on. Let me know in the chats quick, because today's session is gonna be very important, because we are going to solve approximately 100 JEE Mains Organic Chemistry PYQs. And this session will take your NEET preparation to next level. And in today's session, our target, as I have already told you, that our target is to solve these questions with proper understanding, rather than rushing through them. Duration will be 3 to 4 hours. Once again, duration will be 3 to 4 hours, because we have to solve 100 questions. We have not, write down the answers, but we have to understand these reactions. Okay. So without wasting much more time, let's get started. But let me tell you, before we start the session, let me tell you that the handwritten PDF of today's session, I will be sharing on my new Telegram channel, and that is this one. That is this one. If you have not joined the channel yet, do join the channel quickly. Okay. So our first question is, in CH2 double bond C double bond CH single bond CH3 molecule, this is the molecule in which carbon 1 is this, carbon 2, this is carbon 3, this is carbon 4. The hybridization of carbon 1, 2, 3 and 4 respectively are. As we know, this carbon forms what we call a pi bond, and others are its sigma bond. That means this is sp2. This carbon forms 2 pi bond and 2 sigma bond. That means 2 sigma bond. Hence, this is sp. So sp2, sp. After that, this is once again sp2 and this is sp3. So it is sp2, sp, sp2 and sp3. So sp2, sp, after that sp2 and then sp3. That means it is option number D. So this is sp2. After that, it's sp, then it's sp2, then finally it is sp3. This is very simple question. Now, after this, the number of stereoisomers possible for 1,2-dimethyl cyclopropane is, have a look. This is what we call 1,2-dimethyl cyclopropane. Now this 1,2-dimethyl cyclopropane can be like this. Both methyl group will be above the plane. I mean to say it can be like this. Both will be above the plane. Both can be total possibilities. I will write down total possibilities, and after that we will check how many different isomers are possible. Both can be below the plane, or it can be like this. This one above the plane and this one below the plane. Similarly, it can be like this. This one below the plane and then this one above the plane. But we know this molecule is having what we call a plane of symmetry, having two chiral centers, and after that plane of symmetry is present. So this is a meso compound. So this is a mesoform. This is its mesoform. This is also mesoform. But both these, because this is the plane of symmetry, this is the mesoform. But you know, both these forms are identical. So I will write down or. That means these are basically homomers of each other. This is cis form. This is also cis form. But what about this? One is above the plane, another is below the plane. This is trans. This is also trans. But these two trans forms are non-superimposable mirror images. That means these are enantiomers. And we know enantiomers are different compounds. That means they are different. They are different with respect to each other. So in nutshell, these two are same. That means it's one form. These two are different. That means these are two forms. So one form and two form. In total, there are three forms. There are three forms. So total stereoisomers are three. Cis is only one because both are identical, and trans are two. They are enantiomers of each other. I hope this point is clear. Let me know in the chats if this question is clear to each and everyone. If this question is clear to each and everyone, let me know in the chats quick. Let me know in the chats, my dear lovely students. This session should be very much interactive. You have to answer me. You have to answer me. Come on, quick. Is this point clear to you? Is this question clear to you? Come on, everyone. Okay, that's great. That is great. Now, if this question is clear to you, then let's move towards another question. Question says, which one of the following compounds does not exhibit resonance? Which of the following compounds does not exhibit resonance? First one is this one. It is CH3CH2. Then obviously it's OCH double bond CH2. Second one, C6H5. That means it's a phenyl ring. Then it is CH2, then it's OH. And third one, this is CH3, have a look, CH2, then it is CH, double bond CH, single bond CH2, single bond, it is NH2. In fourth one, there is CH3, CH2, CH2, then it is C double bond O, then it is NH2. Now we know here, it's a lone pair of electron, it can take part in resonance like this. Yes or no? Here, these pi electrons can take part in resonance. This lone pair will not, because this is not in conjugation. This lone pair will not take part in conjugation, and this pi and this lone pair, they are not in conjugation, so there will be no resonance. But here will be resonance. Now the question is, you have to tell me in these compounds, which of the following does not exhibit resonance? So this one does not exhibit resonance, so it is simply C. It is very, very simple question. Is this point clear? Everyone please, let me know quickly. Is this point clear to you? Is this point clear to you? Everyone, quick. Everyone has to answer me, because these are JEE questions, and you will see few questions are of a very good level. Now, tell me, is this point clear to you? Is this point clear to you? Okay. Someone is saying that it is dimethyl cyclopropane. Yes, it is not it's not pentane. It's not pentane. It's propane. It's propane. So let me draw this in this fashion. Let me draw this in this fashion. It's not. Thank you very much. It's not pentane. It's propane. In this question, it's not pentane. It's propane. But the explanation is one and the same. Explanation is basically same. Explanation is same, and that explanation is not, correct for cyclopentane. That explanation which I have basically explained is correct for this cyclopropane. This and this, they are meso, that means identical forms, homomers, but these are trans, but they are different forms. So this is what we call this one. Thank you and God bless you. Thank you and God bless you. After this, this is also clear to you. Now, after this, my dear lovely students, tell me the answer of this question. I will be waiting for the answer. Which of the following resonating structures is least stable? Resonating structures are given. You have to find out least stable resonating structures. Not only you have to find out least stable, you have to tell me why least stable. Why least stable? First, which form is least stable? And after that, you have to tell me why that form is least stable. Come on, quick. Come on, everyone. Waiting for your answer. Quick. Now, my dear lovely students, let me know the answer quickly. Come on, my dear lovely students. Everyone. Waiting for the reply. I'm waiting for your response. Come on, everyone. I'm waiting for your response. Sir, can't see question. Okay. Is this question visible to you now? Is this question visible to you now? Is this question visible to you now? Come on, everyone, come on. It's basically a double bond over here. Then it's a single bond. These are single bonds. This is double bond. Here it is nitrogen. Here it's a positive charge. Here it's a positive charge. Here it's a negative charge. Here it's single bond O having negative charge. And this is having O. Come on, everyone. Then second option is like this. It's double bond, single bond, single bond, single bond. Then it's nitrogen. Then double bond O, single bond O having a negative charge. This is a positive charge on this nitrogen and negative charge on carbon. So this is option number third. Positive over here. Then single bond, then double bond, then single bond, then once again double bond, then nitrogen. Nitrogen is having a positive charge. Then oxygen is having a negative charge. Now come on, quick, tell me the answer. Tell me the answer, guys. Tell me the answer, my dear lovely students. This is positive, this is negative. This is oxygen having negative charge. Come on, everyone. Tell me the answer. Exactly, it is option number 1. Because we know whenever like charges are present at two adjacent positions, then this resonating structure is considered as least stable resonating structure. So its answer is option A. This is the least stable resonating structure. Now after this, we have another question in which there is what we call a CH2 positive attached to benzene ring or a phenyl ring. This is option A. After that, you are having CH2 double bond CH, that means a vinyl carbocation. After that, you are having CH3 CH2 with a positive charge. That means ethyl carbocation is C. So benzyl carbocation, vinyl carbocation, then ethyl carbocation, and finally you have ethynyl carbocation, and this is D. You have to tell me the stability order. Tell me the stability order, guys, quickly. Tell me the stability order. Very, very quick. Very, very quick. Tell me the stability order. It's very simple. Very simple. First one is stabilized because of resonance. That means A is the most stable carbocation. Only one option is there. So we can simply say option D is the right answer. After that, we know this is sp3 hybridized carbon. 2 hybridized carbon. This is sp2 hybridized carbon. This is what we call sp2 carbocation is having sp2 hybridization. This is also this is sp hybridization. We know among these, first one, this one is stable because of alpha hydrogens as well as hyperconjugation. In these two, this is less electronegative, this is more electronegative carbon. More electronegative carbon having positive charge is least stable. That's why first it is A, then it is C, then it is B, and at the end it is D. After this, we will be having a statement-based question. Statement 1 says, hyperconjugation is a permanent effect. Second, hyperconjugation in ethyl carbocation, that means CH3CH2 positive, involves overlapping of carbon hydrogen, but that carbon is sp2 with one s bond with, carbon hydrogen. In carbon, it's sp2 hybridized orbital, and hydrogen, it's 1s orbital with empty 2p orbital of other carbon. Tell me the answer quick. Tell me the answer quick. Very simple question. Very simple question. First part is hyperconjugation what we call a permanent effect? Answer is yes. After that, in hyperconjugation, overlapping of what? Overlapping of what takes place? In hyperconjugation, overlapping of what takes place? It is basically CH bond of alkyl group. And here, as per carbocation is concerned, it's what we call sp2 orbital of this. And then it is sp3, and this carbon should be sp3, but it's saying that carbon is sp2. So the other, what we call statement second is wrong. Statement first is correct, but statement second is wrong. First is correct and statement second is false. Very, very simple question. After that, question is like, Mesithyl oxide is a common name of. Mesithyl oxide is a common name of. What is meant by mesithyl oxide? You know, it's like this. Mesithyl oxide is like this. You know. This is mesithyl oxide. This is actually mesithyl oxide. When you number this parent chain, so this becomes a substituent. So it is 4-methyl, then total carbons in parent chain are 5, so pent, then 3N, 2-on. So it is 4-methyl, pent, 3N, and then 2-on. That means it is option number 1. It's option number 1. After that, dear students, compound with molecular formula C3H6O. Molecular formula of a compound is C3H6O. When you calculate its GU is 1. And when you look towards its general formula is CnH2n and O. Whose general formula is this? It is basically, we know, this is either aldehyde, this is either ketone, or it is cyclic alcohol. It is what we call, it can be cyclic ether. Dear students, it can be what we call unsaturated alcohol. It can be unsaturated alcohol, and it can be unsaturated ether. So my dear lovely students, if you are having C3H6O, then their what we call molecular formula can be same, but their functional groups are different. What are those isomers whose functional groups are different? They are simply known as functional group isomers, and the phenomenon is simply what we call functional group isomerism. So C3H6O can show functional isomerism because these can be having similar molecular formula, but dear students, their functional group is different. So whenever you put value of N equals to 3, it becomes C3H6O. This is very, very simple question. After that, question is the IUPAC name for the following compounds. First of all, you know, this is COOH, I mean say the main functional group or the principal functional group of this compound. This is CHO, that means this is having more than one functional group. This compound is having more than one functional group. That means it's a polyfunctional compound. Now, whenever you are having polyfunctional compound, what is rule 1? Rule 1 is identification of principal functional group. So this is principal functional group and this is chain terminating. So we will write down this 1, this 2, this 3, this 4, this 5 and this 6. Now, this is aldehyde whose carbon has been included in the parent chain. When your aldehyde carbon is included in the parent chain and it acts as a substituent, then we call that as oxo. So it is oxo, it's oxo as a substituent, and it is methyl which are substituents at 2nd and 5th position. So it is 2,5-dimethyl, then it is what we call 6-oxo. So 2,5-dimethyl, 6-oxo. In total there are 6 carbons, so hex. At 3rd position it's double bond, so 3N and oic acid. So the name of this compound, correct name of this compound is simply this option number C, 2,5-dimethyl, 6-oxo and then hex 3-enoic acid. I hope this point is clear. I hope this point is clear. Now after that, there is another question. After that, there is another question. Let me know in the chats quick. Is this visible to each and every one? Is this visible to each and every one? Is this visible to each and every one? And try to solve this question. Try to solve this question. Very, very, very simple question. Very simple question. Try to solve this question. This is A. Then this is B. Question says, among the following compounds, geometrical isomerism is exhibited by. We know for geometrical isomerism, there should be at least 2 centers where rotation is restricted or hindered. We know that. Now tell me, dear students, which one can show geometrical isomerism? Tell me quick. Tell me quick. There are conditions for geometrical isomerism. There are conditions. One condition is there must be 2 centers where rotation is restricted. After that, each center must contain different groups and all those groups should be present within the same plane. Now tell me which one? And groups should be different with respect to each other. Have a look, dear students. Have a look. When we talk about this, across carbon-carbon, double bond. If we divide this molecule into 2 equal halves, then across carbon-carbon double bond, there is restricted rotation, hindered rotation, but here C is having 2 groups similar. Similarly, this C is having 2 groups similar. That means this cannot show geometrical isomerism. But if we look towards this carbon-carbon, I mean say double bond, across carbon-carbon double bond, have a look. This carbon is having H and Cl, that means 2 different groups. This carbon is having this part different and this part different. That means it can show geometrical isomerism. Similarly, if you look towards this carbon-carbon double bond, here hydrogen Cl are different, but this part and this part, they are identical. This cannot show geometrical isomerism. Similarly, here across carbon-carbon double bond, HCl are different, but this carbon is having similar part. That means it cannot show geometrical isomerism. So geometrical isomerism is shown by only option B. After that, we have another question, dear students, and once again a question has been asked from IUPAC nomenclature. That means IUPAC nomenclature is very important as per organic chemistry is concerned. Now tell me, dear students, how many functional groups are there? There are 2 functional groups. One is OH, that means of alcohol. Another is of carboxylic acid. We know when there is more than 1 functional group, that means for polyfunctional compounds, we have to find out principal functional group, and principal functional group is this. If this is principal functional group, dear students, then what will happen? This is 3, this is 4, this is 5. this becomes substituent, and this OH will act also as a substituent. This is hydroxy, this is methyl, so it is 3-hydroxy, 4-methyl, and then pentanoic acid. 3-hydroxy, 4-methyl, pentanoic acid is the option D. After that, my dear lovely students, try to solve this question. Try to solve this question, dear students. A very, very good question. Come on, try to solve this question. It's a very, very, very good question. Try to solve this question. Come on, dear students, try to solve this question. Question says 3-methyl pent-2-ene. 3-methyl pent-2-ene. 3-methyl pent-2-ene. This is 1, 2, 3. Then this is 4. This is 5. 3-methyl pent-2-ene on reaction with HBr. On reaction with HBr. Have a look. On reaction with HBr. But in presence of peroxide. In presence of peroxide. Which type of reaction is this? This is simply peroxide effect. Anti-Markovnikov's product will be obtained. Anti-Markovnikov's product will be obtained. Yes or no? Now, have a look. 3-methyl pent, it is not pent-1-ene, it's pent-2-ene. It is pent-2-ene. It is pent-2-ene. It is 3-methyl pent, I mean to say 2-ene. So, let me erase this one. It is 3-methyl because this is 1, this is 2, this is 3, this is 4, this is 5. 3-methyl and then pent-2-ene. On addition of HBr, what will happen? Have a look. It is simply CH3, CH2, CBr. But this is according to Markovnikov. We have to form anti-Markovnikov. That clearly means that Br goes to that carbon-carbon double bond which is having more number of hydrogens. That means Br goes to this position and H goes to this position. So this is the product formed during this reaction. This is anti-Markovnikov's product. Is this point clear to you? Now, question says forms an addition product. This is the addition product. Number of possible stereoisomers of the product. You have to find out number of stereoisomers for this. Now have a look. Have a look, my dear lovely students. This is a chiral center. This is a chiral center. This is also a chiral center. That means for this, we can simply say as chiral center is 2. Therefore, total stereoisomers, we know, total stereoisomers, I mean to say, total stereoisomers is having the formula 2 raised power n, as this is unsymmetrical. So it is 2 raised to the power 2. Answer is 4. Answer is 4. So it is option B. Option B is the right answer. The number of possible stereoisomers will be, it is 4. I hope this point is clear. Let me know in the chats, is this question clear to you? Let me know in the chats quick. Let me know in the chats quick. Is this question clear to each and everyone? Is this point clear to each and everyone? Let me know in the chats quick. Let me know in the chats quick. Quick, 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 dear students, quick. Sir, doubt. Where is the doubt? Where is doubt, beta? At the rate of known, I don't know the full form, known deny. Amir. Okay, where is the doubt? How n value is 2? There are 2 chiral centers. This is one chiral center. This is also chiral center. So n value is equal to 2 over here, because here n means optical isomer area, and we know chiral center is one optical isomer area. This chiral center is another optical isomer area. There are n is 2. So 2 raised to the power 2 is 4. After that, question is like this. Question is like this. Have a look. Question is, you are having a compound like this, CO2H. That means this is carboxylic acid. After that, it is OH, and then H, then it is Cl, then here it is H, then CH3. You have to find out the configuration. You have to tell me the configuration. First of all, we know this is a chain terminating functional group, so this is our parent chain. Now, I can write down this in this fashion. CO2H, then it is OH, H, then can I write down this carbon in the form of C, Cl, H and CH3. Now have a look. Now have a look. With respect to this chiral center, this, and this, these are 4 different groups. We have to assign priority to them. So first priority goes to this one. Second priority goes to this carbon because it is having Cl attached to it. So this is 2, this is 3. So this is first priority, this is second priority, this is third priority, and this is having fourth priority. That means at this chiral center, we are having 1 on this side, 3 on this side, and 2 on this side. Have a look. 1, 2, 3 means clockwise. It means clockwise. Clockwise means R, but we have to change this R and we will tell its configuration is S. Why? Why we have changed R to S? That rule is known as golden rule. And why we use golden rule? Because least priority is on horizontal line. And in case of fissure, that means vertical and horizontal structure, whenever least priority is on horizontal line at a chiral center, whatever is the configuration, you have to change that. That means the configuration of this carbon is, I mean to say, S. After that, let's have a look on this chiral center now. Have a look. It's like this now. It is Cl, it is H, it is CH3. Then we are having a carbon like this. Then it's having OH, H, and COH. That means it's having OH, it's having H, and it is having CO2H. That means COOH. Now, we have to find out the priority of this one, and this whole group. Because we have to assign configuration to this chiral center now. Cl will be 1. Cl will be 1. After that, above group will be 2. This group will be 3. This group will be 4. Now, have a look. It is like this. 1 is here, 2 is here, 3 is here now. So 1, 2, 3, it is anti-clockwise direction. Anti-clockwise direction means S, but we have to change S to R. Once again, a golden rule. Why golden rule? Because least priority is present on, your fourth priority is present on horizontal line. So it becomes R. That means this becomes R. Now have a look. According to the numbering of a parent chain, it is second carbon which is S. So I will write down it is 2S, and it is third carbon which is R. So I will write down 2S, 3R. 2S, 3R is option B. 2S, 3R is option B. I hope this point is clear to each and everyone. I hope this point is clear to each and everyone. Exactly at the rate of Rimuru, at the rate of Kavya, at the rate of Samvitha Parkha, at the rate of Mobina J, exactly, you have given me the right answer, beta. You have given me the right answer. After this, try to solve this question. Come on, quick. How many chiral compounds are possible on monochlorination of 2-methyl-butane? This is 2-methyl-butane. 2-methyl-butane is this one. 2-methyl-butane is this one. Upon monochlorination, this is simply a free radical substitution reaction. You have to tell me how many chiral compounds are possible. First of all, you should know how many different types of hydrogens are present in this. As there are 4 different types of hydrogens, then Cl can replace any one hydrogen. If Cl replaces one hydrogen of A, then the product will be simply like this. A product will be simply like this. It replaces A hydrogen by chlorine. So any one hydrogen of A will be replaced, then this will be A. This will be the product formed from A. Then product formed from B can be like this. Product formed from B can be like this. It is B. Product formed from C will be like this. That means replace C hydrogen by chlorine. Replace C hydrogen by chlorine. This is product C. Then what will be product D? That will be simply replace one hydrogen from position D. Replace one hydrogen from this position D. This will become simply what we call our fourth product. Now, have a look. This carbon is chiral. This molecule is having one chiral center, hence this is a chiral molecule. This does not have any chiral center. This is not a chiral molecule. This is having one chiral center. That means this is once again a chiral compound. This is not a chiral compound. So, how many chiral compounds are there? How many chiral compounds are there? One is this one. This is a chiral compound. Another one is this one. This is also a chiral compound. So you have to tell me. You have to tell me how many chiral compounds are there. How many chiral compounds are there? There are 2 chiral compounds. So the answer is this one. So the answer is this one. I hope this is clear. I hope this is clear. Yes, at the rate of Karthik Ji, exactly it's A. At the rate of Mubena J, it's exactly A. Exactly A is the right answer. Very, very good. After that, the number of stereoisomers possible for a compound of the molecular formula, this one. This is the compound. This is the compound. This is the compound. This is the chiral center. We know because of this chiral center, there can be obviously 2 isomers. One is R, another is S. Similarly, as per double bond is concerned, one is E and another is Z. That means one can be cis with respect to hydrogen, another can be trans with respect to hydrogen. That means there will be cis trans 2 and RS2. That means in total there are 4. So answer is 4. Answer is 4, dear students. After that, which one of the following conformations of cyclohexane is chiral? It's very simple. You know, cyclohexane is having infinite number of conformations, but the most important conformations are chair, what we call half chair, boat, and twist boat. And twist boat is the only conformation of cyclohexane which is, say, chiral because of absence of plane of symmetry, center of symmetry. So it is twist boat. After that, dear students, question is in front of you. Let me know, is this visible to each and everyone? Is this slide visible to each and everyone? Is this slide visible to each and everyone? Let me know quickly. First option is like this. It is CH, this is NH2. This is, say, what we call Fischer structure in which it is COOH and H. That means this is an amino acid. But this amino acid is having 2 hydrogens similar attached to a carbon. Now here it is like this. CHO, then it is OH over here. Here it is H. Here it is CH2OH. Third one is like this. Question says that which of the following molecules is expected to rotate plane of polarized light? You should know that any compound which rotates plane polarized light is basically a chiral compound. That means which can rotate plane of polarized light in any direction is a optically active compound. So you have to find out optically active compound. And in general, most of the times, chiral compounds are optically active compounds, except amines in which amine inversion takes place, and similarly carbanion in which there is one chiral center, but because of inversion that is optically inactive. Now tell me, what is the answer? Answer is this one, because this is having one chiral center, so this is chiral molecule, hence optically active. If this is optically active, when plane polarized light is passed through it, the plane of polarized light will be deflected either towards right or towards left. That means it rotates plane polarized light. So you have to choose which is expected to rotate plane polarized light. So it is option B. After that, increasing order of stability among 3 main conformations of 2-fluoroethane. What is meant by 2-fluoroethane? Have a look. This is basically 2-fluoroethane. Ethanol. 2-fluoroethanol is this one. It is 2-fluoroethanol. So what will be the stability, or what will be their, yes, increasing order of stability? For that, let me draw a structure over here. So this is one of the structures. This is one of the structures. This is one of the structures, and this structure is a staggered form. We know this, and this staggered is NT form. This is its NT form. We have another structure like this. We have another structure like this. Say this is F now. Then this is what we call F goes to this position. That means H goes to this position and H goes to this position. This is partially eclipsed. That means this is an eclipsed form, but partially eclipsed one. After that, it is once again OH. This is H. This is H. After that, it is F. This is H. This is H. This is known as gauche or gauche form. After that, we have another form, important form of this, and that important form is like this. This is fully eclipsed form. This is fully eclipsed form. Both these forms are eclipsed. These forms are eclipsed. And this, they are staggered forms. And we know in case of staggered form, repulsions or strain is very less as compared to eclipsed form. So staggered is more stable than eclipsed. But among staggered, among these two, among NT and gauche, in gauche there is what we call hydrogen bonding. So among staggered, it is basically gauche which becomes more stable here as compared to NT, and after that it is eclipsed. So this is the stability order. But this is decreasing order of stability. You have to tell increasing order of stability. That means this is less stable, then it is NT, then it is gauche. That means eclipse first, then NT, then gauche. Eclipse first, then NT, then gauche. That means it is option number C. I hope this point is clear. I hope, Betaji, this point is clear to each and everyone. Is this point clear to each and everyone? Is this point clear to each and everyone? Okay. After this we will be having another question, and question is like this. First, you are having a carbocation. You are having a carbocation like this. Have a look. This is the carbocation. This is the carbocation. It's a benzyl carbocation. Then you are having a carbocation like this. This is carbocation B. This is A carbocation. This is B carbocation. And then you are having a C carbocation in this fashion. You are having C carbocation like this. This is C, dear students. And finally, you are having a carbocation like this. And this is D carbocation. You have to tell me which one is more stable, or what will be the resonance stabilized carbocation species among the given species. Resonance stabilized carbocations. You have to find out which carbocation can show resonance, which carbocation can show resonance. First one can show resonance easily. Second one can show resonance easily. In third, there is no resonance. There is no resonance because this positive charge and pi bond, they are not in conjugation. There will be no resonance because we know this positive charge is present in an orbital which is out of plane as compared to this pi bond. So there are these two options where resonance takes place. Hence, it will be simply A and B only. It will be A and B only. After this, question is like this. Tell me the answer quickly. Tell me the answer quickly. Question is like this. You have to tell me the answer quick. This is the question. This is the question. With benzene ring, there are three groups attached to it. One is OH, another is CH3, another is NO2. And there is basically concentrated HNO3, concentrated H2SO4. That means reaction is nitration reaction. You have to tell me the major product of this reaction. You have to tell me the major product of this reaction. Have a look. Reaction says if you are having OH, CH3 and NO2 in this fashion, and if it is treated with HNO3 concentrated and H2SO4 concentrated, that means nitrating mixture is there. So these two will generate, this H2SO4 will generate NO2 positive from nitric acid. Now, where will this electrophile goes? Have a look. This is what we call orthopara directing, or these are activating groups. This is deactivating group. So electrophile, this electrophile will take position, and that will be decided by strong activating groups. Among these two, strong activating group is this. So this NO2 will go to ortho positions of OH or para position of OH, but This ortho is blocked. That means it will not go to this position. So this position is not possible now. That means the product at this position is not possible. Why? Because this is already blocked. Now, this is another position of, I mean to say, this OH. But if electrophile goes to this position, there will be repulsion. Say, for example, NO2 came here. There will be repulsion, steric repulsion. That's why electrophile will not prefer this position. So electrophile will prefer which position? Electrophile will prefer this position. That is why, my dear lovely students, it is option C, which is the right answer. I hope this point is clear. I hope this point is clear, dear students. I hope this point is clear, beta. I hope this point is clear. Is this point clear to you? Is this point clear to you? Are these options visible now? Are these options visible now? I hope these are visible because I can clearly see them on my mobile. These are visible now. Okay. So I hope you will answer now easily if question like this came in your NEET. Now, after this, which of the following compounds will form the precipitate with aqueous AgNO3 solution most readily? Waiting for the answer of this question. Let me know the answer of this question in the chats. Quick. Let me know the answer of this question in the chats. Waiting for your answer. Waiting for your response. Come on. Is it A? Is it B? Is it C? Or a D option? Let me know quickly. Let me know quickly. Which option is the correct one? Which option is the correct one? Quick. Which option is the correct one? At the rate of Chaturya, it's C. At the rate of Rimuru, C. At the rate of Muhammad Rizwan, C. At the rate of Savitha, C. Deepak Wama, C. At the rate of Siri, C. No. C is not the right answer. C is not the right answer. This is very, very simple question, my dear lovely students. Have a look. Have a look. What does that mean? Which among these will form a precipitate with aqueous AgNO3? That means this is actually normal SN1 reaction. That means just try to break this, say Br bond, and here it will be a carbocation which will be formed on this nitrogen. To this carbon attached to nitrogen. Similarly, it will result in the formation of a carbocation on this carbon which is directly attached to nitrogen. Similarly, here it will be a carbocation formation. Here it will be a carbocation formation. And you know, this lone pair can stabilize the carbocation because of resonance, or you can simply say back bonding. This can also stabilize the carbocation because of back bonding. This cannot stabilize the carbocation because of back bonding. That means this is less stable as compared to these two. This can also stabilize the carbocation because of back bonding. But, dear students, this lone pair is available. These lone pairs of nitrogen and oxygen, they don't take part in any other phenomenon. But this lone pair takes part in resonance. That means it's not that much available for back bonding with, say carbocation. That means this is less stable. But these two are more stable as compared to this. This is more stable as compared to this. But among these two, this is nitrogen, this is oxygen. Oxygen is more electronegative. That means its lone pair will be tightly held. Hence, it will not take part in back bonding that easily as lone pair of nitrogen, because lone pair of nitrogen is loosely bound. Hence, the carbocation formed over here will be more stable. That is why Br can be lost in the form of Br minus, and that Br minus will react with Ag. That means AgBr will precipitate very, very fast. So, which among these can form, precipitate easily, means which among these can form more stable carbocation, or which among these can undergo SN1 reaction faster. So, whenever question is like this, that which will form precipitate easily, readily, at that time, you have to think about rate of reactivity of SN1. That means you have to think about rate of stability of carbocation. I hope this point is clear to each and everyone. I hope this point is clear to each and everyone now. So it is option number B. Dear students, it's option number B now. Is this point clear to everyone now? Is this point clear to everyone now? Quick. Okay, that's great. That is great. After this, we will be having another question. We will be having another question. Is this slide clear to you? Let me also check. Let me also check. Yes, this is clear. This is clear. Question says, correct order of stability for the following oxides. These are the oxides. You have to tell me the correct stability order. Have a look. This oxide is stabilized by minus I of this nitro group. This is stabilized because of resonance. This is stabilized because of resonance. But we know here it is basically like this. It is basically like this. This structure is basically like this. Let me draw structure like this. It is double bond O, and then it's O having a negative charge, and this is a positive charge. That means here it is one position, then it's another position, then it's another, position. That means there are three conjugate positions. Extended conjugation is there. More resonance is there. So in this case, resonance is more. In this case, resonance is more. In this case, resonance is more as compared to this. So C is most stable, after that B, and after that A. More resonance makes it more stable. Then this is having stabilized because of resonance. This is stabilized due to minus I. So that's why C, B, and A. C, B, and A is the right option. That means it's option number A. After that, the increasing order of basis T for the following intermediates is. Now tell me, what will be the decreasing order of basis T? What will be the decreasing order of basis T over here? First of all, have a look. All these species, which basically due to which this can act as a base is carbon, this is carbon, this is carbon, this is carbon, this is carbon. And you should know, basis T, one of the formulas is like this. Basis T is inversely proportional to stability of that species. More stable that species is inversely proportional to stability of that species. Basis T of any species, you should know, is inversely proportional to the stability of that species. This is one of the formulas. There are many ways to explain basis T, but this is one of the formulas. That means you have to check which one is most stable. Have a look. Have a look. This is, let me write down over here. It is C triple bond N having negative charge. That means this is having sp hybridization. After that, it is HC triple bond C negative. This is once again having sp hybridization. After that, this is sp2 hybridized carbon. After that, dear students, this is sp3 hybridized carbon. This is also sp3 hybridized carbon. We know when negative charge is present on similar types of elements, at that time, that element which is having more electronegativity, that means which is having more S character, negative charge on that is more stable. That means this is most stable. This is most stable. After that, it is this. After that, it is this. After that, it is this. And finally, it is that. I hope this point is clear. So that clearly indicates this is the most stable, means this is weaker base. This is weaker base. Yes or no? That means if this is weaker base, I will write down 5 first. That means 5. After that, 3, because this is third. So 5, 3, 2. After that, it's 4. After that, it's 1. So it will be like this. 5 is weaker base because this is the most stable, say negative charged species. After that, it's 3. After that, it's 2, 4, and 1 is the strongest base. 1 is the strongest base among these one. I hope this point is clear. 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 Okay, that is great. After this, there is question, the increasing order of reactivity of the following compounds towards aromatic electrophilic substitution reaction. We know rate of aromatic electrophilic substitution reaction is simply directly proportional to electron density of the aromatic ring. Directly proportional to electron density of the ring. Directly proportional to electron density of the aromatic ring. Yes or no? Yes or no? Now, look towards these compounds. This is Cl. Cl is having minus I power greater than its plus IR. That means it will simply deactivate the ring. It will decrease the electron density of the ring. This is plus R group. It will increase electron density of the ring. This is CH3. It shows hyperconjugation. That means it increases, it will donate, it increases electron density of the ring. It will decrease electron density of the ring. Now, tell me, it increases the electron density of the ring. That clearly means it will show aromatic electrophilic substitution very fast. That means you have to write down increasing order. That means it should be at the end. So B should be at the end. There is only one option where B is at the end. That means it is this one. So B should be at the end. After that, it is C, obviously. After that, it should be A and finally D, because this withdraws electron because of more stronger minus R as compared to this inductive effect. So this will deactivate this ring. Here, electron density will be very less. That's why D is, that aromatic compound which shows aromatic electrophilic substitution very slowly as compared to this. So it is D first, it shows slowly, then this will show faster as compared to that, then C will show faster as compared to A, and B will show fastest among these all. I hope this point is clear. I hope this point is clear. I hope this point is clear. Let me know quickly. Is this point clear? Is this point clear? Is this question clear to each and every one? Dear students, after that, we are having a question. The increasing order of nucleophilicity. Dear students, what is meant by nucleophilicity? That clearly means strength of nucleophile. That means a tendency of a nucleophile to form a covalent bond with electron deficient site of the substrate. Now, these are the nucleophiles. You have to tell me which one is stronger nucleophile and which one is weaker nucleophile. Let me tell you. These are having, first one is like this, CH3, C double bond O, O negative. Second one is H2O. Third one is CH3, S double bond O, and O having negative charge. Fourth one is O having a negative charge. That means nucleophilic centers here are same. When nucleophilic centers are same, listen carefully. When nucleophilic centers are same, at that time nucleophilicity parallels basicity. That means nucleophilic order as well as basic order will be same. But these three are negatively charged oxygen. This is, what we call neutral oxygen. Neutral oxygen is weaker nucleophile as compared to negatively charged nucleophiles. That means second will be the weakest one. That means second will be weakest one, means either it is A or it is B option. After that, so we will write down first, it is weaker one. Weaker one will be water. After that, when we compare these three, your answer, you can explain answer in different ways. Say for example, this and this, all three are negatively charged species. Let me erase water because water is the weaker nucleophile. Among these, you can form their conjugate acids. Its conjugate acid is CH3, COOH. Its conjugate acid is sulfonic acid. So one is carboxylic acid, another is sulfonic acid, another is water. We know among these three acids, water is weaker acid. Weaker acid is having strong conjugate base, and whatever is the basicity order, that will be the nucleophilicity order. That means this is stronger nucleophile among these three. This is strongest acid among these three. It's having weaker conjugate base, means weaker nucleophile. So among these three, weaker nucleophile is this one. That means it is 3. After that, it is first one. After that, it is 4. So it is 2, 3, 1, 4. 2, 3, 1, 4 means it is option number 1. It is option number 1. Very, very simple question. Very, very simple question. After that, the increasing order of pKa values. So questions are given over here. Have a look. Questions are here. This is phenol. This is also phenol, but to this phenol, there is minus R group. This is phenol. Here at meta position, it shows, minus I, because due to its minus R, there is no effect on acidic character of phenol. This is plus R group. And there is only hydrogens attached to this, I mean to say phenyl ring, but hydrogens neither show plus I nor minus I nor plus H nor minus H if they are attached to carbon-carbon double bond, neither plus I nor minus I. That means I can simply say it's neutral species. Now we know strength of acid, whenever you have to find out strength of acid, first you have to write down minus R, then minus H, then minus I, then that species which does not show any effect. After that, it is plus I. After that, it's plus H. After that, plus R. After that, you have to write down plus R. So you know this one. But if these groups are more than one, then you have to write down strong first and then weak. Similarly here, you have to write down weak first and then strong. Now have a look. These are N minus R minus I plus R. First of all, we have to write down minus R. Minus R means it is B, which is stronger acid. After that, minus H is no one. Then C minus I. Then neutral is A. After that, we will write down D. So this is strength of acid, but decreasing order. You have to tell me strength of acid, but in increasing order. What will be the increasing order of this? That means reverse of this. That is D, A, C, and B. This will be simply strength of acid, but in increasing order. But we have to tell pKa. We know strength of acid is inversely proportional to pKa. Whatever will be the increasing order over here, reverse that. That means it will become B, then it will become simply C, then it will become A, then it will become D. I hope this point is clear. That means D is having highest pKa value. Because this is a weaker acid. I hope this point is clear. So it is B, C, A, and D. B, C, A, and D. Is this point clear to you? You have to tell me strength pKa value, but we know pKa is inversely proportional to strength of acid. That means lowest pKa is having that one which is stronger acid. Lowest pKa is of B because this is strongest acid. Then after that it's C because C is little bit weaker acid than B. After that it's A because A is weaker acid than, I mean to say, C. After that it will be D because D is, I mean to say, weakest acid among them. Is this point clear? So D is having highest pKa because this pKa is in increasing order. D is having highest pKa. Highest pKa means weakest acid. Lowest pKa means strongest acid. So it is BCAD. BCAD is the option number D. Option number B. After that, the order of stability of the following carbocations. Carbocations are given. You have to tell me the order of stability. Come on quick. Yes, this is visible. Tell me, beta. This is allyl carbocation. This is stabilized because of resonance. This is stabilized because of inductive effect or hyperconjugation. This is also stabilized because of resonance. More resonance, less resonance. So 3 first, after that 1. 3 first, after that 1, after that 2. 3, 1, 2, 3, 1, 2. It is 3, it is 1, then it is 2. After this, the electrophile E positive attacks the benzene ring to generate intermediate. These are the sigma complexes or Wieland's intermediates, or these are the carbocations. These are the resonance hybrid of that. Now, of the following, which sigma complex among these is of lowest energy? Means which sigma complex is most stable? We know that carbocation is most stable in which, I mean say, there is electron donating group, but there is electron withdrawing groups. Electron donating group is not attached to it. Then we can simply, discuss this question like this. We will simply say that carbocation, that sigma complex, that Wieland's intermediate is less stable in which there are electron withdrawing groups. That means these three are less stable because electron withdrawing groups are present as compared to this. So option C is the most stable, which means option C is having lower energy or lowest energy among these. I hope this point is clear. Now after that, the increasing order of stability of the following free radicals. We know free radicals are stable if they are having more resonance. Now have a look. This is CH3 whole 2CH isopropyl free radical, tertiary butyl free radical. This is, I mean to say, benzyl free radical, biphenyl methyl, that is triphenyl methyl benzyl radical. I mean to say there are these types of radicals are there. CH3, CH and CH3. Now have a look. This is stabilized due to 6 alpha hydrogens. Now this one, this radical is stabilized due to 9 alpha hydrogens. That means this is more stable. So it will be like this. After that, it is biphenyl methyl radical. Biphenyl methyl radicals are stabilized because of resonance. Hence, this is more stable than this. Then it is triphenyl methyl radical, which is most stable among them because of more resonance. So this will be the order of stability. Order of stability is this. That means option A is the right answer. Option A is the right answer. After this, the decreasing order of nucleophilicity among the following, decreasing order of nucleophilicity among the following nucleophiles is, first of all, have a look. We are having a nucleophile like this, CH3 C double bond O negative. Here, nucleophilic site is oxygen. In second case, nucleophilic site is oxygen. In third case, nucleophilic site is, I mean to say, this is ambident nucleophile, but generally nucleophilic site is, I mean say carbon. And in fourth, nucleophilic site is once again oxygen. So, there is one carbon, other oxygens. We know when nucleophiles belong to the same period, then more electronegativity there, lesser will be the nucleophilic character. That means the strongest nucleophile among them is Cn minus, that means third. This is the most, I mean say, stronger nucleophile among these. After this, let me erase this Cn minus, because Cn minus is stronger nucleophile because negative charge is present on less electronegative element. After that, among these three, these all are what we call negatively charged species. We can form acid to them. I mean say its acid will be CH3COH. That means acid is CH3COH, carboxylic acid. Its acid is alcohol. Its acid is sulfonic acid. Sulfonic acid is stronger acid. Stronger acid is having weaker base, means weaker nucleophile. That means this is the weakest nucleophile. After that, it is this one. This will be the strongest nucleophile among these. That means it is 2, which is stronger nucleophile. Then it is 1, which is stronger nucleophile. After that, it is 4, which is stronger nucleophile. That means it will be 3214. 3214 is the option D. So any acid is having weaker conjugate base. Stronger acid is having weaker conjugate base. And whenever you find out the basic character order, at that time nucleophilic character order will be same. Generally, when nucleophilic sites are, I mean say, identical, at that time we call nucleophilicity and basicity is having same order. Nucleophilicity parallels basicity. So form acids of these. Any, I mean say, any base which is having stronger acid is weaker base, means weaker nucleophile. So stronger acid is having weaker base, means weaker nucleophile. After that, excess of isobutane on reaction with bromine. This is isobutane. This is isobutane. This is isobutane. Now this on reaction with bromine in presence of light at 125 degrees Celsius gives which one of the following as the major product? First of all, what is this reaction? This is alkane, this is bromine, this is halogenation of alkane, this is bromination of alkane, and we know bromination of alkane is free radical substitution reaction, but it is that free radical substitution which is a selective free radical substitution. What is meant by that? That means whenever it forms a major product, it always forms a major product from more stable carbon free radical. Now have a look. There are these all 9 hydrogens are of one type. This hydrogen which is attached to this carbon will be of different type. But if we remove this hydrogen, there will be more stable carbon free radical That means the product or the brominated product formed from more stable carbon-free radical is major product during bromination. That means this is the major product of bromination. This is the major product of bromination because bromination is a selective free radical substitution reaction. Now question says, when it is taken in excess with bromine in presence of light, which one of the following is acts as the major product? Simply, it is 2-bromo 2-methyl propane. It is 2-bromo 2-methyl propane. It's 2-bromo 2-methyl propane. That means it's option number D. I hope this point is clear. I hope this point is clear to each and every one. I hope this point is clear to each and every one. Come on, my dear lovely students. Let me know in the chats, is this point clear? Is this point clear? Now, after this, there is a question. Arrange the following conformational isomers of N-butane in order of their increasing potential energy. That means you have to write down first that one which is having lowest potential energy, means which is most stable. Now tell me, what will be the answer? What will be the answer? What will be the answer? Quick. What will be the answer, dear students? What will be the answer? Waiting for your response. Come on, quick. What will be the answer? What will be the answer of this question? What will be the answer of this question? What will be the answer of this question, dear students? What will be the answer of this question? Come on, come on, come on. This is very, very simple. Very, very simple. Now have a look. This first is NT form. This is NT form. That means a staggered form. This is gauche. This is gauche. That means a staggered form. This is what we call fully eclipsed. That means eclipsed form. This is partially eclipsed. That means eclipsed form. We know stability is like this. This is the most stable conformation. If it is most stable conformation, it's having lowest what we call potential energy. That means it is 1. After that, it will be 3 because gauche is more stable as compared to eclipse. And among eclipse, it is partially eclipse which is more stable. And after that, it is fully eclipse, which is, say, least stable. So this is most stable, so lowest energy. After that, 3, then 4, then 2. So it is 1, 3, 4, 2. Exactly, it is the option number A. Option number A is the right answer at the rate of Maruthi, Mobinaji. Exactly, you have given me the right answer. After this, there is statement-based question. First statement is 2-methyl butane on oxidation with KMnO4. 2-methyl butane. 2-methyl butane. 2-methyl butane. It's like this. On oxidation with KMnO4 gives 2-methyl butan 2-ol. 2-methyl butan 2-ol. This is first statement. Let me tell you, this is alkane. Alkanes show resistance towards oxidation with KMnO4. But if alkane contains a tertiary carbon which is having hydrogen, that means if alkanes are having tertiary hydrogen, then they can undergo oxidation with KMnO4 and that hydrogen is replaced by OH group. That means this is exactly correct. This is exactly correct. Alkanes having tertiary hydrogen only gets oxidized to alcohol by using KMnO4. Otherwise, alkane without tertiary hydrogen cannot be oxidized by means of KMnO4. That means statement 1 is exactly correct. Then N-alkanes, matlab normal alkanes. N-alkane means normal alkanes can be easily oxidized to corresponding alcohols. This is wrong because N-alkanes cannot be oxidized to alcohols by using KMnO4 because N-alkanes do not have any tertiary hydrogen. So statement 1 is correct, but statement 2 is incorrect. Statement 1 is correct, but statement 2 is incorrect. So it is option B. It is option B. After this, which of the following reagent is used for the following reaction? I am waiting for the answer of this question. Come on. This is alkane. How can you convert alkane to aldehyde? Let me know in the chats quick. This is an alkane. A very good question. This is an alkane. You have to tell me how this alkane is converted to this one. You have to tell me how you can convert alkane into aldehyde. You have to use, say one of these. Tell me the correct answer. Which reagent is used for this conversion? Which reagent is used for this conversion? Come on. Answer me the question. Answer me this question. Answer me this question. This is simply question from NCERT textbook. Come on. Tell me. A is not the right answer because if you use A, at that time one of the hydrogens will be replaced by OH. That means we will get alcohol. If you use manganese acetate, then three hydrogens from the same carbon will be replaced by 3 OH groups. Finally, it will lose water molecule and we will get acid. If you use potassium permanganate, this is normal alkane. There is no tertiary hydrogen. There will be no oxidation. But if you use molybdenum oxide, MO2O3, then remember, dear students, you have to remove 2 hydrogens from the same carbon. Then it becomes CHOH. Finally, it will lose water molecule and it becomes aldehyde. This is the question from your NCERT text. This is very, very simple. But I hope this point is clear. Oh no, it is molybdenum oxide, option number B. Because this converts this into alcohol. This will convert this alkane into carboxylic acid, but it cannot convert this alkane into alcohol at all. Now, after this, question is, in the following reaction sequence, you have to tell me what is A. You have to tell me what is A. Here, what is A? What is A over here? Come on. Come on, everyone. Which type of reaction is this? First of all, tell me which type of reaction is this? And after that, tell me what will be the A as major product. But that major product should be monobrominated. It's written in the question that should be monobrominated. Now tell me, which type of reaction is this? At the rate of Rimuru, B. At the rate of Manohar, B. Akshay, B. Okay. Which type of reaction is this, first of all? This is side chain halogenation. This is side chain halogenation, also known as benzylic halogenation, side chain bromination, or benzylic bromination, and it's a free radical substitution reaction. That means this benzylic position will get bromine. That means one of the hydrogens of benzylic position will be replaced. One of the hydrogens of benzylic position will be replaced by bromine. So it will be the product. So it is like this. It is like this. Which option is this one? It's option number B, because this group and CN, they are at meta position with respect to each other. They are at meta position with respect to each other. So this is benzylic bromination, side chain bromination, or simply free radical substitution reaction. After that, the gas evolved on heating CH3MgBr in CH3MgBr, very, very simple reaction. CH3MgBr in methanol. Tell me, what will be the gas which will be evolved over here? The gas evolved over here. Simple. This is Grignard's reagent. This is negative part, this is positive part. And in alcohol, this is positive part and this is negative part. That means alcohol can donate H positive, so it can act as acid. That H positive will be accepted by this. That means this can act as a base. This is normal acid-base reaction. So CH3 minus will accept hydrogen. It will form methane, and this MgBr will accept, this OCH3, so it will form methoxymagnesium bromide. So this is the gas which has been evolved during this reaction. That means it is methane. Methane is the first option. I hope this point is clear. Which type of reaction is this known as? What is the name of this reaction? It is simply Zerevetinov's reaction. It is simply Zerivatinov's reaction. What is meant by Zerivatinov's reaction? Reaction of Grignard's reagent with any acidic hydrogen containing compound resulting in the formation of alkane. I hope this point is clear. Now, next question is on your screen. Let me know in the chats what will be the answer. Which branched chain isomer of the hydrocarbon with molecular mass 72 gives only one isomer of mono-substituted alkyl halide? First of all, it's neopentane. Neopentane is this one. This is neopentane. Its molecular mass is 72. So obviously it is this one. And it's having only one type of hydrogen. So it's having only one type of hydrogen means it will give only one mono-substituted alkyl halide. This is hexane. Their molecular formula is 86. And this is not, hydrocarbon at all. You have to tell me which hydrocarbon with molecular mass 72 gives only one, what we call alkyl halide or mono-substituted alkyl halide. It is simply neopentane. After that, 2-methylpentane on reaction with 2-methylpentane is this one. 2-methylpentane on reaction with bromine, that means halogenation once again, free radical substitution reaction, gives mainly, I have already told you that whenever halogenation of alkane is bromination of alkane, bromination is a selective reaction and major product will be always formed from that, by replacing that hydrogen by bromine, which hydrogen can result in the formation of more stable carbon free radical. That means it is obviously this tertiary hydrogen. So the product of this reaction, major product of this reaction will be like this. Major product will be like this. That means, dear students, 1, 2, 3, 4, 5, it is 2-methyl and 2-bromo. So it is 2-bromo, 2-methylpentane. 2-bromo, 2-methylpentane. 2-bromo, 2-methylpentane. Is there any 2-bromo, 2-methylpentane? Okay, sorry, this is butane. This is not pentane. This is butane. This is butane. This is butane. 1, 2, 3, and this is 4. This is not pentane. Now it is 2-bromo, 2-methylbutane. 2-bromo, 2-methylbutane is this one. 2-bromo, 2-methylbutane. After that, which one of the following is reduced with zinc and HCl? Which type of reaction is this? Zinc and HCl. Two corresponding hydrocarbon. Which converts which type of compound is converted to hydrocarbon by using zinc amalgam HCl? Do you know which type of reaction is this? This is simply Clemmensen reduction. Clemmensen reduction. And we know this can be either aldehyde, it can be aldehyde or ketone. Now have a look. This is ethyl acetate. So it is ethyl acetate. So it is ester. Acetic acid, that means it's a carboxylic acid. Acid amide, that means that is an amide. So this is butanone. Obviously, this is ketone, which can be converted to hydrocarbon by using Clemmensen reduction. Simple, very simple reaction. After that, let me know in the chats what will be the major product of this reaction. I will be waiting for this answer because this is a very good question. Many students make mistake in this question. Many students did, mistake generally in this question. Many students give wrong answer generally in this question, and I want to check whether you will give me the right answer or the wrong one. Come on, everyone. Come on, everyone. Let me know in the chats what will be the answer of this question. What will be the answer of this question? Quick. You have to tell me the major product. You have to tell me the major product of this. You have to tell me the major product of this. Generally, students give wrong answer of this question. I want to check whether you will give right or wrong. At the rate of Rimuru is saying B. At the rate of Manohar is saying B. Mohammad Rizwan is saying B. So once again, Namrita is saying A. Pranitha is saying B. Bilvashri is saying B. Madara is saying D. Now that means no one is giving me the right answer. Have a look. Have a look. Which type of reaction is this? Have a look. It is like this. It is very, very simple reaction, but you have to understand this reaction. You have to understand this reaction. It is simply double bond is there and HBr is there. So HBr will be added to carbon-carbon double bond, but to that carbon-carbon double bond which can form more stable carbocation, because this is electrophilic addition reaction. So it will be added to this, Br minus will be lost. First of all, dear students, have a look. It will result in the formation of this one. This is the most stable carbocation. Yes or no? But it can undergo resonance and its resonating structure will be like this. Its resonating structure will be like this. So this is A, this is B. A is major. A is, say more stable. A is more stable. B is less stable. Now listen carefully. Listen carefully. When Br minus now attacks, it can attack a carbocation here and here. There will be no rearrangement basically in these carbocations now. So the final product can be like this. Either Br goes to this position or Br goes to this position. Have a look. This is formed from more stable carbocation. That means this can be formed very easily. This is kinetically controlled product. This rate of formation of this will be very, very, very high. This is thermodynamically controlled product. This is thermodynamically controlled product because this product is more stable as compared to this. Have a look. This is carbon-carbon double bond. This is alpha carbon. This alpha carbon does not have any hydrogen, but this carbon-carbon double bond is having alpha carbon, alpha carbon, alpha carbon, 3, 3, 6 and 2, 8. It's stable due to 8 alpha hydrogen. So this is more stable. More stable. Thermodynamically controlled product is more stable. Rate will be less, but its rate will be more. This is kinetically controlled, that is thermodynamically controlled. But listen, beta, thermodynamically controlled product will be obviously major product because this is more stable as compared to this. Once this is formed, it will get converted to this one. So the major product of this reaction is, remember, it is this one. It is this one. Because this gets finally converted to that. This will be formed, say rate of formation of this will be more because this is kinetically controlled product because it has been formed from more stable carbocation, but finally that will become the major product because this will get converted to that because this is less stable as compared to this. This is more stable as compared to this. I hope this point is clear. I hope this point is clear. I hope this point is clear. Let me know in the chats quick. Is this point clear to each and everyone? Okay, that is great. That is great. After this, the major product obtained from E2 elimination. E2 elimination of 3-bromo 2-fluoropentane is, this is not 3-bromo 2-fluoropentane. This is not basically the right question because this is something different and this is something different. Let me change the question. Let me write down the proper question actually. Question is this one. Question is this one. So the major product of the following reaction is basically different. This is not the right question here. Question says actually like this. Question says actually the major product of the following reaction is major product of the following reaction is major product of the following reaction, and reaction is in front of you. Tell me the answer. Tell me the answer quick. Major product of the following reaction is, tell me the answer, dear students. Reaction is like this. There is CH3, then it is CH3, it is CH3, then it is CHOH, then dear students CH3, finally it is written concentrated H2SO4 a few drops. That means actually what has happened, have a look. This OH actually gets protonated first. With this H positive, it gets protonated. So let me write down H positive over here. This H positive came from H2SO4. So first it is protonation. So it is protonation first. It becomes a good leaving group first. After that, it will lose water molecule. When it loses water molecule, it forms a carbocation. So it will form a carbocation like this. It forms a carbocation like this. Carbocation is obtained like this. After that, dear students, there will be 1,2 methyl carbanion shift. There will be 1,2 methyl carbanion shift, so as to form more stable carbocation like this. So as to form more stable carbocation like this. Finally, what will happen? H positive will be lost. This H positive will be lost and we will get CH3, CCH3, double bond C, CH3 and CH3. So we will get 2,3-dimethyl-but-2-ene. 2,3-dimethyl-but-2-ene is the right answer. That means it is option number C. Exactly, Muhammad Rizwan has given me the right answer. Exactly, C is the right answer. C is the right answer, dear students. C is the right answer. Exactly, Mubina J. C is the right answer. Now, try to focus on these questions. Your NEET is on 21st. So try to focus on these questions. Now, there is a question in which assertion A and reason is R. So what is assertion? Treatment of bromine water with propene yields 1-bromopropanol. Have a look. It says you are having propene. You are having propene. On treatment with bromine water, that means it is Br2, what we call H2O, or it is what we call HOBr, in which OH is negative part, Br is positive part. So what will be the product? Negative part goes to that carbon-carbon double bond, which is having lesser number of hydrogen. That means it's like this and like this. So obviously 1, 2, 3, it is 1-bromo. Propan 2-all, obviously. Yes, treatment of bromine water with propene yields this one. That means statement 1 is correct. Now, assertion is correct. Reason says attack of water on bromonium ion follows Markovnikov's rule and results in 1-bromopropanol. Obviously, it has been, formed during reaction with the help of Markovnikov's rule. Have a look. I will show you a little bit mechanism over here, because your mechanism part should be good as per electrophilic addition reactions are concerned. So this is propene. With bromine water, what will happen? What will happen first? First, it will simply results in the formation of cyclic bromonium ion. Br minus will be lost and this will form a cyclic bromonium ion like this. Cyclic bromonium ion will be formed. Then attack of water. Water goes to that carbon of basically carbon-carbon double bond, which is having lesser number of hydrogen. That means water will attack to this. That means attack of water on this bromonium ion follows Markovnikov's rule. Yes, when it attacks on this carbon, that means its negative part, OH, goes finally to this one. Let me lost H positive directly. So its negative part finally goes to this position. So negative part of water finally goes to that carbon-carbon double bond, which is having lesser number of hydrogens. That means assertion is this one and reason is the correct explanation for that. That means assertion is true but reason is false. No. Assertion is false. No. Both assertion and reason are true and reason is the correct explanation of, assertion. This is option C. Option C is the right answer. After that, the stereoisomers that are formed by electrophilic addition of bromine to trans-but-2-ene is very, very simple reaction. you should know this one. This is very, very, very simple. This bromination, addition of bromine means bromination. It is anti-addition reaction. Anti-addition reaction. This is anti-addition reaction. And we know whenever you are having cis alkene, and if reaction is anti-addition, it gives, reaction is what we call anti-addition, we generally get racemic mixture at that time. That means two enantiomers will be formed in equal proportion. But if alkene is transalkene, upon anti-addition gives basically two compounds but which are identical because both are meso compounds. They get mesoforms or meso compounds. That's why trick for this is C, A and R, that means car, cis alkene anti-addition racemic mixture, and for this it is T, A and M, that means it is inverse mat T, A and M. So it is here trans alkene, trans anti-addition because it is anti-addition meso compound. That means we will get two identical mesomers. We will get two identical mesomers because here two enantiomers are obtained. Here two compounds are identical because both are mesoforms. So two mesoforms are obtained. Okay. Then there is a question, but before that, let me check and you also tell me whether this slide is visible to you. Whether this slide is visible to you, tell me. Yes, this is visible. This is visible. This is visible. Now, first it is alkene. Question is like this. It is alkene, cycloalkene, which on treatment with KMnO4, H2SO4, that means acidic KMnO4, which is, we know, which is a strong oxidizing agent. What will strong oxidizing agent do with, say alkene? We know if it is having CH, then you have to break this one, convert CH into COH, convert CH into COH. That means it becomes COOH. And then finally it is this one. This carbon and this carbon becomes COH and all CH2, 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 CH2 remains there. After that, same alkene on treatment with KMnO4, water, but 273 Kelvin. That means this is cold dilute alkaline KMnO4. That means this is Bayer's reagent. We know Bayer's reagent on treatment, alkene on treatment with Bayer's reagent gives syn hydroxylation product. That means diol is obtained. Here dicarboxylic acid is obtained and in this diol is obtained. A is this one. So A is dicarboxylic acid. B is diol. A is dicarboxylic acid and B is diol. That means it is compound. A is dicarboxylic acid. That means option C. And B is what we call diol. I hope this point is clear. After that, another question is this one. Another question says, if you are having a structure like this, if you are having an alcohol, on treatment with concentrated H2SO4, that means on treatment with protonic acid, what will happen? It will first result in the formation of protonated alcohol. It will result in the formation of protonated alcohol first. Then finally, this protonated alcohol will be lost in the form of water and we will get a carbocation. This carbocation is resonance stabilized. Finally, upon heating, this hydrogen will be lost and it will result in the formation of this one. It will result in the formation of this one. But this can be, say cis as well as trans. This can be trans as well as cis because this carbon-carbon double bond can be also like this. It can be also formed in this fashion. That means both the compounds can be obtained in equal proportion. That means we will get cis and trans both. Both compounds are formed, but they are not formed equally. Why? Because this is trans form. Trans form is more stable. This is cis. Between this and this, there will be steric repulsion. That means this will be minor. This will be minor, this will be major. Both are formed, but they will not be formed in equal proportions because trans is more stable, hence that is major product as compared to cis. So both compound A and B are formed equally. No, compound A will be major. Yes, compound A will be major product because A is trans. A is trans, trans is major product. I hope this point is clear. After that, another question. Another question says that you are having an alcohol like this. Here it is OH, here it is CH3. It's a tertiary alcohol. Tertiary alcohol on treatment with 20% H3PO4 at a temperature of 358 Kelvin results in the formation of what? It obviously results in the formation, it undergoes dehydration. First, OH will be lost in the form of OH2 positive, carbocation will be formed, and finally, major product will be SADZEF. Major product will be SADZEF product. SADZEF product. Because it basically results in the formation of this one first. It results in the formation of this one first. Now, hydrogen from these positions will form SADZEF product. Hydrogen from this position, if we remove hydrogen from this, then it will be a Hoffman product. So this is the major product. SADZEF will be the major product. And minor product will be this one. This one will be the minor product. Now the question says, this is what we call major product. This is A. This is major product. Okay, this is A. This is A. After that, second reaction is like this. Second reaction says like this. But here, base is tertiary butoxide, potassium tertiary butoxide. We know this is a bulky base. When bulky base is there, E2 elimination takes place, but it prefers to remove hydrogen from that carbon where repulsion will be less. Obviously, it will prefer to remove hydrogen from this carbon because repulsion will be less as compared to this. So we will get major product here as this one. This one will become major product in this reaction. And minor will be obviously this one. Minor will be this one. That means here, this is Hoffman, this is SADZEF. So in this example, Hoffman is major product, but here it is SADZEF which is major product. You have to tell me what is A. A is this one and this one is B, because major we have to tell major product. So this is B. Option number A is the right answer. Option number A is the right answer. Let me know quickly, is this reaction clear to you? Is this reaction clear to you? Let me know in the chats quick. Let me know in the chats quick. Is this reaction clear to each and every one? Is this reaction clear to each and every one? Okay, that's great. Which of the following is Lindlar's catalyst? This is simple question. It is partially deactivated. It is obviously partially deactivated. Partially deactivated pallidized charcoal. It is Lindlar's catalyst. What is Lindlar's catalyst? Lindlar's catalyst is palladium, calcium carbonate plus sulfur or quinoline. So it is pallidized charcoal. Sometimes it is like this. It's written on your NCRT. It's like this. So with small amounts of sulfur or quinoline. So option number B is the right answer. After that, tell me from this to this, which types of reagents or what is the condition for the reaction? I mean, say which among these is the correct answer? Which among these is the correct answer? Very, very simple. This is very, very, very simple reaction. It is simply this is simply allylic halogenation, allylic chlorination. And we know allylic chlorination takes place in presence of light or at high temperature. That means it is this one. It is simply this one. Chlorine in presence of light or chlorine at high temperature. Now tell me, what will be the major product? Major product of this reaction. You have to tell me major product of this reaction. Major product of this reaction. Come on everyone. Major. You have to tell me the major product of this reaction. And this is what we call acidic hydration. This is acidic hydration reaction. Now have a look. First, it will abstract hydrogen, water will be lost. First, it results in the formation of a carbocation. It results in the formation of a carbocation. Then, ring expansion here takes place. That means I will break this bond and form here. That means it results in the formation of a ring like this. 6-membered ring will be formed now. This bond will be broken and it will be in this form. It will be like this. So this will acquire a positive charge. This will acquire a positive charge. So can I write is in this fashion. It's a 6-membered ring. 6-membered ring. To 6-membered ring, there is CH3 and there is CH3 to its adjacent position as well. But this position is having positive charge. Yes or no? Then finally, hydrogen will be lost because of heating. Hydrogen will be lost and we will get a 6-membered ring in which double bond is there, and to both carbons of double bond there are CH3 groups. So it is option number B. Option number B. Option number B is the right answer. Come on everyone. Come on everyone. Come on, be very much attentive. Be very much attentive. Now, the major product obtained from E2 elimination of 3-bromo-2-fluoropentane. Now, it is a question like this. 3-bromo-2-fluoro. 3-bromo-2-fluoro. It's like this. 3-bromo-2-fluoro. 3-bromo-2-fluoropentane. 1, 2, 3, 4, and 5. E2 elimination. E2 elimination. Whenever it takes E2 elimination, say for example a strong base is there and heat, so E2 elimination. Now we know a better leaving group is bromine. That's why I will call carbon to which bromine is attached as alpha and this is beta. From beta position just remove hydrogen and from alpha just remove what we call halogen. So its product will be like this. So it will be a carbon-carbon double bond. To one carbon-carbon double bond, there will be CH3 and fluorine. To another, there will be CH2 and CH3. That means this one. To one carbon-carbon double bond, F and CH3 is there. And to another carbon-carbon double bond, it's H and CH2, CH3. It's like this. It's like this. Is this point clear? After this, bromination of cyclohexene. Bromination of cyclohexene. Under conditions given, that means bromine in presence of light. Which type of reaction is this? Bromine in presence of light or bromination at high temperature? It is simply allylic bromination. Allylic bromination means it's option D. Allylic bromination means it's option D. It's option D. It's option D. It's option D. After that, which compound would give 5-keto-2-methyl hexanol upon ozonolysis? We know upon ozonolysis what we have to do is we have to break double bond, form double bond O here, double bond O here. Now, what is this compound? This is 1, 2, 3, 3-methyl, 4, 5, 6. Now this is 3-methyl, but we have to find out 2-methyl. That means this is not the compound. Now just try to break this. Oxygen and oxygen, 1, 2, 3, 4. 4-methyl, no, this is not the answer. Just break this one. This is O, this is O. 1, 2, 3, 4, 5, 6, 7. No, this is not the answer because we should get hexanol. If this bond is broken, it's oxygen. So this becomes aldehyde, 1, 2, 2-methyl, 3, 4, 5, 6. So that means 2-methyl, then it is 5-keto. Yes, 1, 2, 3, 4, 5. 5-keto hexanol. This will be the answer of this question. This will be the answer of this question because what will be the product of this? Have a look. Product of this will be like this. It is CH3. Then it is double bond O over here. CH2, CH2, C, CH3. Then it is C, double bond O, and it is H. Two functional groups are there. One is aldehyde, another ketone. Ketone is not the principal functional group. Two functional groups are there. Aldehyde is the principal functional group. I will number this 2, 3, 4, 5, and 6. This becomes keto. So it is 2-methyl, 5-keto, and we get hexane 1-ul or hexanal. So this is the right answer. This is the right answer. So this is from ozonolysis question. Question, you have to match. These are the chemicals and this is the use, preparation, or the constituent. Now, alcoholic potassium hydroxide. What is the use of alcoholic potassium hydroxide? Beta elimination. Beta elimination. That means A is 3. A is 3 means these two. A is 3 means these two. Now, palladium barium sulfate. Palladium barium sulfate means Lindlar's catalyst. That means B is 4. B is 4. B is 4. That means A3B4. So it is clear. A3B4. That means it's option 2. A3B4, benzene hexachloride, obviously 2, and then polyacetylene, they are generally used in electronics or they can be used as electrodes in batteries. So obviously it is option number B. After that, which one of the following carbonyl compounds cannot be prepared by addition of water on an alkyne in the presence of HgSO4 and H2SO4. Let me tell you. Have a look. This is one of the alkynes. Another alkyne can be like this. RC triple bond. This is H. Then alkyne can be like this. That neither of hydrogen is present. That means both should be other than hydrogens. Now, when you add, I mean to say water. That means Koch-Arrow's reaction in presence of HgSO4, H2SO4, and you heat it. What will happen? Double bond is broken because water, you have to add water across carbon-carbon double bond according to Markovnikov's rule if it is unsymmetrical like this. If it is symmetrical, it's up to us. So I will simply form a product like this in first case. So this will be the product. This will be the product in first case. And in last, it will be the product like this. That means 2 hydrogens here, oxygen here, 2 hydrogens here, oxygen here. But here, you have to add according to Markovnikov's rule. That means here we should add oxygen to this and finally hydrogen to this. Now have a look. This is ketone. This is ketone. This is aldehyde, but only one type of aldehyde. This is known as ethanol or acetaldehyde. So remember it forever that whenever alkyne undergoes hydration, known as Koch-Arrow's reaction, whenever alkyne, any type of alkyne undergoes Koch-Arrow's reaction, it generally forms ketone or it can form aldehyde, but that aldehyde which is formed during hydration of alkyne or during Koch-Arrow's reaction is only ethanol. Now, this is ketone, this can be formed. This is ketone, this can be formed. This is acetaldehyde or ethanol, this can be formed. But this is an aldehyde which can never be formed during Koch-Arrow's reaction. So, question says which of the following cannot be prepared during Koch-Arrow's reaction. So, obviously, it is option number B. It is option number B. Let me know in the chats if everything is clear till now. Let me know in the chats if every question is clear till now. Come on, quick. Let me know quickly, beta. We have basically, at the rate of Birapa, we have basically 2 parts of this JEE Mains previous year questions. In one part, we will be solving questions from GOC, questions from, say hydrocarbons, and questions from haloalkanes and haloarenes. And rest of the questions we will discuss in part 2. Rest of the questions we will be discussing in part 2 on Tuesday. Now, come on. For the given reaction is CH3CH double bond. Let me write down over here. Let me write down over here. It is CH3, CH, double bond CH, single bond Br. This on treatment with strong base first. What will happen? On treatment with strong base, it first forms what we call alkyne, like this. It will form propyne. It will form propyne. Hydrogen will be lost from this position and Br will be lost from this position. That means it is normal E2 reaction. It's E2 reaction basically. Now, this is a very strong base, so this will be formed. This is propyne. This propyne on treatment with red hot iron tube. Red hot iron tube at 873 Kelvin. What will be the product? We know here cyclic polymerization will take place and it will result in the formation of mesitylene or 1,3,5-trimethyl benzene. I hope this point is clear. So which among these can be formed? Obviously it can be 1,3,5. That means 1,3,5-trimethyl benzene, which is known as mesitylene. After that, question says, have a look, everyone have a look. Okay. Have a look, beta. What is the question? What is the question? Have a look. Question says, if you are having acetylene or ethine, this ethine on treatment with first LiNH2 and ether. That means this is basically a strong base, Li positive, NH2 minus. It first results in the formation of this one. It will abstract H positive, then it's negative, Li positive. This on treatment with, as this is a stronger nucleophile, now this will react with CH3, CHBr, and then it is CH. To this CH, it is CH3 and CH3. CH3 and CH3. That means this is isopropyl. Isopropyl is attached to CH. To that, it is Br and it is, CH3. That means it is 2-bromo-3-methyl butane. 2-bromo-3-methyl butane. Now, what will happen? Over here, simple SN2 reaction. It will attack this one and Br will be lost. So, we will get HC triple bond C. Then that C will form bond with this CH. This CH is having bond with CH3 already. Then it's having another CH. Then it is having CH3. Then it is CH3. Is this point clear? So this is P. Now, after this, my dear lovely students, this P is treated with HgSO4, H2SO4. That means actually you have to add water. This is basically Kocharov's reaction. Now, where to add water? Water should be added across carbon-carbon triple bond according to Markovnikov's rule. That means final product will be like this. CH3, C double bond O, and then it is CH-CH3, then CH-CH3, then it is CH3. This is basically a ketone. This on treatment with NaBH4. That means NaBH4 will reduce this ketone by breaking this bond, add hydrogen to this, hydrogen to this. So we will get an alcohol first. Here we will get an alcohol first. And alcohol is like this. Now, let me show this one over here. Now, this is alcohol. This alcohol is basically the product Q. Now, this alcohol on treatment with beta, H2SO4 concentrated. What will happen? Have a look. This OH first abstracts proton, becomes OH2 with a positive charge, then that water will be lost. Let me show you over here that OH will be lost in the form of water. It will form first a carbocation. Over here. So it will result in the formation of this one. It will form a carbocation over here first. Then this hydride shift will take place. So we can simply say 1, 2 hydride shift takes place. Once this hydride shift takes place, it results in the formation of CH3, then CH2, then it is CH3 with a positive charge, then it is C, it's H, it's CH3, it is CH3. Finally, beta, this hydride will once again shift. That means another hydride shift takes place. And it forms CH3, CH2, then CH, then CH3, then it is C, CH3, CH3 with a positive charge. Finally, upon heating, H positive will be lost. H positive, this H positive will be lost, so there will be a double bond between these two. That means there will be a carbon-carbon double bond. To one carbon-carbon double bond, there are two methyl groups, and to other, there will be methyl and ethyl. That means carbon-carbon double bond should contain two methyl and another methyl and ethyl. That means it is option C. This is the right answer. Let me know in the chats if I am clearly audible and visible to each and everyone. And second thing, is this clear to each and everyone? Let me know in the chats. Is this clear to each and everyone? Let me know in the chats. Quick. Let me know, beta, in the chats if this is clear to each and everyone. Let me know quick. Let me know quick. Okay. That is great. That is great. Now, after this, we are having another question. And question says that you are having this propyne. You are having this propyne. Have a look. Have a look. You are having, first of all, CH3. You are having this one. You are having CH3, CH, CH3, C triple bond CH. This on treatment with H2O, HgSO4, H2SO4. That means once again hydration reaction, and water adds across carbon-carbon double bond according to Markovnikov's rule. So we will get this one. C double bond O, and this will get CH3. So this is beta X. This X beta on treatment with C2H5 MgBr. Listen carefully, this is negative part, this is positive part. This negative part will go to this one, bond will be broken. So we will first get CH3, CH, CH3. Then it is C, to this C, it is C2H5 which has been added, and here it is already CH3. Then it is OMgBr. Finally, upon treatment with water, it results in the formation of CH3, CH, CH3. This is C, it becomes OH, then it is C2H5, finally it is CH3. This is, say, on treatment with concentrated H2SO4. This on treatment with concentrated H2SO4. What will happen? This OH will abstract H, becomes OH2 positive, finally it will be lost. So let me remove water over here and form directly what we call a carbocation over here. So it will form a carbocation over here. It will form a carbocation over here. Finally, this carbocation undergoes 1,2 hydride shift. 1,2 H minus shift takes place. And it results in the formation of CH3, C, CH3 with a positive charge over here. This becomes CH, this becomes C2H5, and this is CH3. Finally, dear students, H positive will be lost because of heat. This H positive will be lost. There will be double bond between them. So it is CCH3, CH3, double bond C, C2H5 and CH3. That means there is a double bond between carbon and carbon. To one carbon, there is two methyl. To another carbon, there is one methyl, one ethyl. Now, which option is the right answer? Which option is the right answer? Double bond. Methyl, methyl, and methyl and ethyl. It is option number A. It is option number A, dear students. Am I clear? Am I clear till now? Am I clear till now? After this, the major product of the following reaction is major product of the following reaction is? Tell me, beta. Major product. You have to tell me major product. What should be the major product of this reaction? What should be the major product of this reaction? What should be the major product of this reaction? It's alcoholic potassium hydroxide, and then second one, sodamide and liquid ammonia. This is basically two consecutive E2 reactions. With the help of this, two consecutive E2 reactions takes place. That means from this position and this position. First, say for example, bromine hydrogen, then bromine hydrogen. In nutshell, there will be a triple bond between these two positions. So there will be a triple bond between these two positions. So but1 ion will be the product. But1 ion will be the product. That means this is the final product of the reaction. This is the final product of the reaction. After this, lovely students, question is, trans alkene are formed by reduction of alkynes with, tell me, alkene is formed by reduction of alkyne, and that reaction is known as partial reduction of alkynes. Now the question is, when is trans alkene formed from alkyne? That reaction is known as Birch reduction, and reagents are sodium in liquid ammonia or lithium in liquid ammonia. Because by using H2PdCbASO4, we get cis alkene. But question here says we should get, trans alkene. That's why it is sodium in liquid ammonia. After that, benzene on nitration gives nitrobenzene in presence of HNO3 and H2SO4 mixture. Where? Tell me. Whenever nitration of benzene takes place with the help of nitrating mixture, HNO3 acts as a base. It will never act as an acid, and actual acid of that reaction is H2SO4. So the question is, HNO3 acts as a base and H2SO4 is the actual acid of that reaction. I hope this point is clear. I hope this point is clear, beta, to everyone. I hope this point is clear to everyone. I hope this point is clear to everyone. After that, identify A in the given chemical reaction. You have to identify A. What is A? This is simply 2-methyl hexane. 1, 2, 3, 4, 5, 6. This is 2-methyl hexane. We know N-hexane on treatment with, say for example, MO2O3 or Cr2O3 or V2O5, and in presence of alumina at high temperature 773 Kelvin and 10 to 20 atmospheric pressure, results N-hexane. This is basically aromatization reaction. N-hexane forms benzene. N-heptane or 2-methyl, what we call hexane, results in the formation of toluene or methyl benzene. So the answer of this question is this one. This is the final product of this reaction, and this is the major product. After this, the major product of the following reaction. Major product of the following reaction is, have a look. We know when you are having this one on treatment with H2SO4, means in protonic acid, what will happen? Protonation of this will take place, and it will result in the formation of this. There will be no rearrangement of this carbocation as this is stable. After that, it will attack benzene ring. It will attack benzene ring and will act as an electrophile. So the product of this reaction will be like this. This carbon will be attached to benzene. After that, it's CH3 on one side, and then C, to which NO2 group is attached, is on another side, and then it is CH3. So this will be the product of the reaction. This will be the product of the reaction. So first, it should be carbon to which CH3 is attached, carbon to which CH3 is attached. After that, another carbon to which NO2 and CH3 is attached. That means it's option number C. It is option number C. It is option number C. Is this clear? Everyone, let me know in the chats. Is this reaction clear to you? Is this clear to you, beta? Everyone, let me know in the chats. Is this reaction clear to you? Is this reaction clear to you? Okay, that's great. That's great. That's like my doctors. Now, after this, the correct sequence of reagents used in the preparation of 4-bromo 2-nitro-ethyl benzene from benzene. That means question says, if you are having benzene, from this benzene, you have to convert this benzene into CH2CH3 4-bromo 2-nitro 4-bromo 2-nitro-ethyl benzene. Tell me how to convert this into this. I mean, say which among these is the correct option. Have a look. First, among these, we will treat it with CH3COCl AlCl3. First, here CH3CO will be generated as an electrophile. This electrophile goes to the ring. That means acylation, Friedel-Crafts acylation will take place. Friedel-Crafts acylation will take place. Once Friedel-Crafts acylation takes place, now this is the ketone. Now we will treat it with zinc amalgam HCl. That means Clemmensen reduction will take place, and this C double bond O will be changed to CH2. So this is Clemmensen reduction. So we will get ethyl benzene. Now this ethyl benzene on treatment with HNO3H2SO4, HNO3H2SO4. Have a look. HNO3H2SO4 results in the formation of two products. It can form two products. One is ethyl, this one, and another is this one. Now these can be separated with the help of distillation. Finally, we will separate this one. We will separate this one with the help of distillation. We will separate these. Now, then this ortho-nitro-ethyl benzene, upon removing, I mean say separation, this ortho-nitro, I mean say this one, ortho-nitro is now treated with what we call bromination, AlBr3. Now, bromination, that means Br positive will go to ortho as well as para, but ortho is blocked, so it will go to para position. So the product of the reaction can be like this. So it is fourth one. Now the question is third one possible? First, it is this one. After this, if we do bromination, this is meta-directing. Bromine should go to, I mean to say, meta position. That means this is not possible. Now, is this one possible? First, bromination of this results in the formation of bromobenzene. It will result in the formation of bromobenzene. I am checking this one. After this, on treatment with CH3COCl, it can go to ortho, it can go to para, but para 1 will be the major product. So it can be like this. Para 1 will be the major product, so it can be like this. Have a look. After that, nitration should go according to this one. Nitration can be done with the help of bromine, because this is ortho-para directing group, and this is what we call meta-directing group. So nitration can be done on ortho and para, but para is blocked, so nitro can go to this position, ortho. So after that, we will get this one. After nitration, we will get this one. Nitration go to this one. And finally, we will do what we call Clemmensen reduction of this, so it will result in the formation of CH2. Yes, this is possible also. That means this is possible, but in this case, you have to remove these, you have to separate these with the help of distillation. Now, first one, benzene on treatment, this results in the formation of meta-nitrobenzene like this. Or, sorry, benzene, it's not meta, nitro can go to any position because this is benzene. So, say for example, it is benzene, it's nitro. Then, BrAlCl3. Now, Br should go to this one, but Yes, this is possible. Now, after that, CH3COCl, CH3COCl, CH3COCl can go to this one. CH3COCl can go to this one. CH3COCl can go to this one. This is not possible. This is not possible. Why? Because our ethyl and nitro should be ortho, but here ethyl and nitro are para. So this is not possible. Sorry, this is not possible. B is not possible. So B is not possible. B is not possible. D is possible. B is not possible. C is not possible. We are checking A. First, it will form nitrobenzene. Then bromine goes to its meta position. Now, it can go to CH2, CH3 can go to this one. This is possible. This is possible. That means it's either A or D. Both are actually correct. But in D, you have to separate, say them by means of this one. So, most appropriate, because here you have to separate ortho and para. So, most appropriate is this one. Most appropriate is this one. First, nitration forms nitrobenzene. Then nitrobenzene on treatment with, say Br2AlCl3. But nitrobenzene is basically, that compound in which electron withdrawing group is present, and electron withdrawing group does not prefer to undergo halogenation because that is a deactivating group. So, beta, this is more appropriate. That means these both can be formed, but this is more appropriate. But the only thing is that you have to separate them by means of distillation. You have to separate them by means of distillation. I hope this point is clear. Now I will erase this whole, so you can simply write down more appropriate answer of this question is option D. More appropriate is answer is option D. Why not A? Because upon A, once it forms nitrobenzene, after that you have to perform an electrophilic substitution reaction of nitrobenzene, but nitrobenzenes generally do not prefer, electrophilic substitution reactions. But here, first, it will result in the formation of CH3COCl, which gets converted to CH2CH3. That means it is ethyl group which is attached to benzene. Ethyl will donate electrons easily, and then nitration can take place. Once nitration takes place, it takes place at ortho and para. But you have to separate ortho and para. So then ortho nitro, ethyl benzene upon treatment with bromine results in the formation of this product. I hope this point is very much clear to you. This point is very much clear to you. Now, after that, the major product of the following reaction, major product of this reaction. You have to tell me major product of this reaction. Come on, let me know in the chats quickly what will be the major product. What will be the major product, my dear lovely students? What will be the major product? Quick. Come on, quick. First, you have to add bromine across carbon-carbon double bond. Add bromine across carbon-carbon double bond. Have a look. This is very, very simple reaction. First, you have to add bromine across carbon-carbon double bond. When you add bromine across carbon-carbon double bond, it is a vicinal dibromide which will be obtained. Then, it is treated with ethanol. That means, my dear students, it is SN1 reaction now. That means form a carbocation over here by breaking CBr bond. But we know this CBr bond, once broken, results in the formation of more stable carbocation, resonance stabilized carbocation because of this ring. That's why I will form carbocation over here. After that, this ETOH, ethanol, will attack on this. It becomes O positive. Finally, it will lose H positive. And the major product of this reaction is OET here and BR here. Is there any option like that? Yes, it is option number D. It is option number D. Let me know quickly, is this reaction clear to you? This is very, very important reaction. Is this reaction clear to you? Then, my dear lovely students, which of the following compounds is not aromatic? Very simple. This is aromatic. Pyridine, this is pyridine, this is aromatic. This lone pair will not take part in delocalization or resonance. This is not the electron which is present in what we call conjugated orbital. So, no need to count these electrons. So, this is aromatic with 6 pi electrons. This is also aromatic with 6 pi electrons. This is also aromatic because this is a negative charge over here. This is not aromatic. This is not aromatic. After that, next question. Question says you have to tell me the major product. You have to tell me the major product of this reaction. Have a look. Reaction is like this. This is the substrate. This is the substrate. This is the substrate. OCH3. This is the substrate. After that, it is CH2, CH2, CH, CH2, Cl, and here it is CH3. Dear students, first it is treated with AlCl3 anhydrous. Now this will abstract this Cl as Cl minus, and we will get a carbocation like this. We will get a carbocation like this. OCH3, then it is like this. We will get a carbocation like this. But here this hydrogen will be shifted in the form of 1,2 hydride shift. So 1,2H minus shift will take place and we will get more stable carbocation. We will get more stable carbocation. We will get more stable carbocation like this. Now, this will attack this one. That means if this is 1, 2, 3, 4, 5, 5-membered ring is obtained. That means we will get a structure like this. We will get a structure like this. We will get a structure like this, that we will obtain a 5-membered ring. But to this 5-membered ring, what will happen? Have a look. A 5-membered ring will be obtained over here, but this will acquire a positive charge. This is having hydrogen. Then, say for example, this is carbon 5, this is carbon number 4, this is carbon 3, this is 2, this is 1. At 1, there is 2 methyl groups. At carbon number 1, there are 2 methyl groups. Now, this H finally will be lost. H will be finally lost. And we will get a structure like this. OCH3 over here, and here it will be a 5-membered ring, and to this 5-membered ring there are 2 methyl groups over here. So this will be the product. That means option number D is the right answer. Option number D is the right answer. I hope this point is clear. This is basically alkylation, Friedel-Crafts alkylation, because this alkyl group has been introduced. This part has been introduced into the ring, but this is intramolecular Friedel-Crafts alkylation. Intramolecular Friedel-Crafts alkylation. What will happen over here? We know this is Kolb's electrolysis, Kolb's or Kolbe's electrolysis reaction. This is Kolbe's or Kolb's electrolytic reaction. Now, what will happen during this Kolbe's electrolysis? Have a look. This bond will be broken and a radical will be obtained. So we will get a diradical over here. We will get a diradical over here. This radical takes part in resonance. Now, what will happen? It will result in the formation of this one. It will result in the formation of this one. Double bond and double bond over here. So we can simply say a hybrid of this in this fashion. We can simply say it's like this, because it will form double bond over here, double bond over here. That means it's option number B. It's option number B. Option number B is the right answer. Come on, dear students. Come on. Tell me. Is this point clear? Is this point clear, dear students? Is this point clear? Everyone respond. Everyone to respond, please. Everyone, let me know in the chats, everyone. Is this clear? Okay. At the rate of Anurag. Yes, sir. Clear. Okay. Everyone. Okay. At the rate of Pyro. Yes, sir. At the rate of Anuradha. Yes, sir. At the rate of Haripriya. Yes. Clear. Very good. Very good. At the rate of Namrita. Clear. At the rate of Matrix. Clear. At the rate of Padmanab. Clear. Okay, that is great. That is great. That is great. That is great. Everyone is attentive. I hope so. Now, this is another reaction, a very, very important reaction. Have a look. Have a look. You are having a structure like this. You are having a structure like this. This on treatment with HBr, and a peroxide is there, C6H5CO whole 2 O2, that means benzoyl peroxide is there. What will happen? We know anti-Markovnikov's addition of HBr will take place. That means product will be like this. Br will be added to this position. Br will be added to this and H will be added to this. So it is this. After this, it is treated with COF2. What is COF2? Reaction of alkyl halide, alkyl chloride or alkyl bromide with COF2. That means heavy metal fluoride is Schwartz process. So it is simply Schwartz process. Halogen exchange will take place. That means we will get a structure like this. CH2, 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 and then it's F. So 1, 2, 3 CH2, 1, 2, 3 CH2 and F, and to that para position it is Br. So it is simple reaction and the product will be like this. I hope this point is clear. After that, we will be having another reaction. Reaction says, presence of which reagent will affect the reversibility of the following reaction and change it into an irreversible reaction. Question says, how can we convert, say this alkane to alkyl iodide? Say this reaction should be reversible, but we know due to formation of this reaction is irreversible. That means we have to remove this one. But this is possible only if this reaction takes place in presence of concentrated HNO3 or HGO, or what we call HiO3, or you can also use HiO4. So you can use any one among these strong oxidizing agents. Now the question is here is only HiO3. So you can write down HiO3. HiO3 is the right answer. After this, in the following sequence of reactions, you have to tell me, there is a sequence of reaction. Now, what is P? What is final product? But that is the major product. Have a look. We are having this one. Reaction is like this. Whenever there is CX bond, and magnesium is there. Magnesium always came in between CX bond. Magnesium comes in between CX bond. That means it is like this. Now, this is having a negative part, this is having positive part. After this on treatment with ethanol means CH3, CH2, O and H. This is positive part, this is negative part. Negative will abstract positive and this positive will go with negative. That means we will get a structure like this, cyclopentane plus it is MgCl, and to this Mg OCH2CH3 will be attached. So we will get cyclopentane as the major product. So cyclopentane will be obtained as the major product. Cyclopentane will be obtained as the major product. I hope this point is clear. After this reaction, for the following sequence of reactions, the correct products are. But what is the sequence of reaction? Have a look. You have bromine and Fe. Together they can form FeBr3. Then FeBr3 reacts with Br2 and they will generate, in nutshell, Br positive. That means this is an electrophile. So electrophile goes to benzene at any position. So we will get bromobenzene. Bromobenzene on treatment with magnesium, dry ether, what will happen? CX, whenever CX bond is there, magnesium is there. Magnesium comes in between CX bond and we will get phenyl magnesium bromide. What is phenyl magnesium bromide? A Grignard's reagent. This is negative part. This is positive part. This on treatment with methanol. Methanol is having H positive, O negative. So just replace negative positive. This is normal acid-base reaction, and we will get simply this one. This is benzene, and we will get here bromine, here it is OCH3, methoxymagnesium bromide will be obtained and benzene will be obtained. So we should know the product is benzene is this, and methoxymagnesium bromide, that means it is this one. This one is the right answer of this reaction. After this, in the given reaction, reaction says it is 3 bromo 2,2-dimethyl. It is like this: 3 bromo 2,2-dimethyl, then butane, 3 bromo 2,2-dimethyl, and then butane. That means you have to number from this side because of lowest locant set. So it is 2,2-dimethyl and 3 position bromo, but we will write down bromo first because it comes first in alphabetical order. So 3 bromo 2,2-dimethyl butane. This on treatment with CH3 CH2OH, I mean say ethanol. You have to tell me what will be the product. What will be the product, my dear lovely students? It is simply SN1 reaction. It is simply SN1 reaction. What will happen? This bond will be broken first. It will result in the formation of a carbocation first. It will result in the formation of a carbocation first, like this. This carbocation undergoes 1,2-methyl carbanion shift. Once this methyl carbanion shift takes place, it results in the formation of a more stable carbocation, like this beta. Once this carbocation is obtained, now we know this CH3CH2OH will act as a nucleophile and it will attack carbocation, but this is a neutral nucleophile. Once it attacks, it acquires a positive charge. Finally, H will be lost. That means H will be lost as H positive. I hope this point is clear. When H is lost as H positive to this position, it will be simply CH3C CH3, and then it is OCH2 CH3 which will be attached, and we will get CH CH3 and CH3 as the product. So this is 1, 2, 3, 4. It is ethoxy group. It is methyl. This is methyl. So I hope this is clear to you. This is ethoxy. So 2-ethoxy 2,3-dimethyl butane. 2-ethoxy 2,3-dimethyl butane. 2-ethoxy 2,3-dimethyl butane is the option number 1. I hope this point is clear to each and every one. Now, after this, the correct decreasing order of densities of the following compound. We know. Density means mass per unit volume. Here, density is directly proportional to molecular mass. This is having highest molecular mass, D. After that, it's C, because this is having bromine and chlorine. This is having chlorine and chlorine. This is only chlorine. This is not having any chlorine. So molecular mass of D is highest. After that, it is C. After that, it is B. After that, it is A. So density is directly proportional to molecular mass, and molecular mass is highest of D, then C, then B, then A. So the density of D, C, B, A will be the answer. Above reaction, this below reaction requires which of the following reaction condition? This reaction requires which of the following condition? Which type of reaction is this basically? Reaction of chlorobenzene with sodium hydroxide, first resulting in the formation of sodium phenoxide, followed by acidification resulting in the formation of phenol, is known as Dow's process. And Dow's process takes place at a temperature. This takes place at drastic condition at a temperature of 623 Kelvin and 300 atmospheres. That means this one. This is also same temperature pressure, but copper is not required there. So it is 623 Kelvin, 300 atmospheric pressure. This is Dow's process basically. After that, the mechanism of SN1 reaction is given. This is the mechanism of SN1. First, alkyl halide forms ion pair. This is known as intimate ion pair. Then these ion pairs will be separated by means of a solvent. So solvent separated ion pair. And finally, we will get the product. A student writes general characteristics based on the given mechanism as: the reaction is favored by nucleophile, weak nucleophiles. Yes, because strong nucleophile favor SN2. So yes, this is correct. Then R positive, that means carbocation, would be easily formed if substituents are bulky. Yes, because if substituents are bulky, there will be steric repulsion in the substituent. Yes or no? Because of the angle 109 degree. This is tetrahedral sp3. But once it forms a carbocation, it becomes 120. That means bulky groups from 109 will move towards 120. That means they will move farther away from 109 to 120. That means steric repulsion will be minimized, and it will prefer to minimize steric repulsion so as to become more stable. Yes. So this point is also clear. R positive would be easily formed if substituents are bulky. Exactly. The reaction is accompanied by racemization. Yes, racemization will be there, but generally partial racemization, but racemization will be there. The reaction is favored by non-polar solvents. No, this is not correct. So which observations are correct? 1, 2 and 3 all are correct. 1, 2 and 3, that means this one, except D. 1, 2 and 3 are correct. Okay. After that, the major product in the following reaction. Major product in the following reaction. Reaction is like this. Reaction is like this. Major product. You have to tell me major product. It is tertiary butyl alcohol. And then heat. It is actually, chunki heat is there. As heat is there, it favors elimination. But this is polar protic solvent. So E1 reaction is this. Now what will happen? First, this one will be broken. Ci bond is broken. And then a carbocation will be formed. Then here, hydrogen is there. Hydride shift will take place. So 1, 2 hydride shift will take place. And it will result in the formation of a carbocation like this. Then once again, this hydrogen will be shifted over here because hydrogen is also there. So once again, 1, 2 hydride shift will take place. 1, 2 hydride shift will take place. And it will result in the formation of this carbocation. This is the most stable carbocation of this reaction. 3, 3, 6 and 7 alpha hydrogen. This will be stabilized by 7 alpha hydrogens. This is stabilized by 3, 2, 5 and 6 alpha hydrogens. This is stabilized by 3, 4, 5 alpha hydrogens. So this is the most stable carbocation. Now finally, what will happen? What will happen? H positive will be lost. H positive will be lost. Major product will be like this. Major product will be like this. So double bond is between carbon-carbon double bond. This carbon contains 2 methyl. This contains 1 ethyl and methyl. That means option C. Option C is the right answer. Option C is the right answer. I hope this point is clear. After this, the decreasing order of reactivity of the following organic molecules towards AgNO3 solution. That means towards SN1 reaction. Towards SN1 reaction means you have to form a carbocation. First will form carbocation like this. Second will form a carbocation like this. This is A carbocation. This is B carbocation. Carbocation of third one will be like this. This will be a carbocation of C. Then this will be a carbocation of D. Now have a look. This is aromatic, means highly stable carbocation. This is aromatic as well as this is stabilized because it is aromatic plus this plus R group is there. That means it is more stable than this one. This is stabilized because of alpha hydrogens. This is electron withdrawing group. That means this is least stable. So which among these can be formed easily? This one. So rate of this B is highest. After that it is A, then it is C, then it is D. So BACD. BACD is the right answer. So whenever you have a question like the decreasing order of reactivity towards AgNO3 solution or precipitate, this means it is that reaction whose rate is dependent on stability of carbocation. That means it is SN1 reaction. After this, the increasing order of boiling points of the major products A, B, C will be. Have a look. First reaction is this one. First reaction is this. In presence of C6H5COO whole 2. It's like this. It's basically C6H5C double bond O, then it is O, then it is C6H5CO. So it is like this, benzoyl peroxide. In nutshell, this is peroxide. This is peroxide. What will happen, beta? During this reaction, addition takes place according to Anti-Markovnikov. So after that, in second, addition of HBr without peroxide, that means Markovnikov's addition should be there. It will be a Markovnikov's addition. Then once again, addition should be according to, say this is symmetrical, so it's up to us how to add bromine and hydrogen. But remember, boiling point is inversely proportional to branching. Boiling point is inversely proportional to branching. Now, have a look. This is having branch, that means its boiling point will be lowest. So it is B. B will be lowest. B will be lowest. B will be lowest means this one. Option number A. B will be lowest. After that, obviously, it will be C and then it will be A. So this is very, very simple. 1-methyl ethylene oxide. It is ethylene oxide. And there is 1-methyl, it means this one. This on treatment with excess HBr. Have a look. On treatment with HBr, what will happen? On treatment with HBr, it will attack from this position. And it will first generates a protonated ether here. Protonated ether will be formed after that. As this oxygen is having a positive charge, it will withdraw electron from this. And finally, Br minus will attack to that carbon which is more sterically hindered, and it will result in the formation of CH3. Then it is CH, this one, CH. To this, Br will be attached. Then it is CH2, CH2, then it is OH. It will be like this first. It will be like this first. After that, as HBr is taken in excess, and this is a primary alcohol, OH will react with this H. Yes or no? So this OH will react with this H, Br minus will be lost. So we will get CH3, CHBr, CH2, OH2 with a positive charge. It will be lost, Br minus will attack. That means it is an SN2 reaction. SN2 reaction. What will be the product? Product will be CH3, CHBr, and then CH2Br. Vicinal dibromide will be obtained. Vicinal dibromide will be obtained. CH3CHBr and then CH2Br. This is the vicinal dibromide. This is the vicinal dibromide. CH3, CHBr and Br. This is geminal dibromide. These are not dibromides. So this is the right answer. This is the right answer. After this, first of all, let me know in the chats if this slide is visible to each and everyone. Is this slide visible to each and everyone? Yes. If you can zoom it, this is visible. It is visible. It is visible. It is visible to each and everyone. Now, have a look. Have a look. Reactions are given. 1, 2, 3, 4 reactions are given. Now the question is, which of these reactions are possible? First one is not possible. Why? Because in first one, there is a resonance. There is resonance taking place over here. There is resonance taking place in CCl. Or let me show you this over here. Have a look. It is chlorobenzene, first one. And we know in case of chlorobenzene, this bond is difficult to break, this one, because it's having a partial double bond character. Because of resonance, hence this bond is strong. As this bond is strong due to partial double bond character as a result of resonance, this CX bond is difficult to break. That means this cannot be formed. Similarly, vinyl halide, CH2 double bond CHCl. Same reason, it is difficult to break. It is difficult to break because it's having partial double bond character. That means it's a strong bond. So it is difficult to break, strong bond. These are very less reactive species. Okay. So these two cannot be obtained. Benzene, chlorobenzene gives this. Yes, this is possible. And benzene and allyl chloride gives this one. This is also possible. That means which of these reactions are possible? B and D are possible. B and D are possible. B and D are possible. A and C are not possible. After this, In the following reaction sequence, structures A and B respectively are. Now have a look. It's a very good question. This is a very good question. It is like this. HBr and heat. What we have to do? Here oxygen is directly attached to benzene. Whenever your ether is such that, this is O, C and C, that means it's ether. But if ether is such that oxygen is directly attached to benzene ring, break this bond, give hydrogen to this, give halogen to this. That means we will get first of all this one. First of all, we will get this one. Then it is CH2, then CH2Br. 1, 2, 3 CH2s are there. One CH2, second CH2, third CH2, and then to this CH2, there is Br. I hope this point is clear. 1, 2, and 3. 1, 2, and 3. After this, there is CH2Br also here. CH2Br is also here. Now this on treatment with sodium and ether, what will happen? Whenever CX bond is there and sodium is there, just try to break these bonds. When you break these bonds, what will happen? What will happen, my dear lovely students? It will form a radical over here. It will form a radical over here. These two radicals will combine together. These two radicals will combine together. Yes or no? When they combine together, they form a ring. They form a ring like this. 1, 2, 3. This and this, they will form a 6-membered ring over here. 6-membered ring over here. So first it is this one. This is A. And this is intramolecular product, which is B. Now you have to choose which one is the right answer. Which one is the right answer? It is this option B. OH, CH2, 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 Br. Yes, yes. Finally, this. It is option number B. Option number B. I hope this point is clear. I hope this point is clear. This is intramolecular Wurtz reaction taking place over here. Now, finally, next question is the decreasing order of reactivity towards dehydrohalogenation, E1 reaction. You have to tell me decreasing order of E1 reaction means you have to form carbocation. In first case, break CCl bond and form a carbocation. This is carbocation of A. In B, what will be the carbocation? Carbocation will be like this. In C, what will be the carbocation? Carbocation will be like this. By breaking CCl bond, you have to form carbocation. And in D, what will be the carbocation? Carbocation will be this one. This is stabilized by resonance plus this methyl group, I mean say hyperconjugation, as well as inductive effect. This is stabilized by resonance only. These two are stabilized by hyperconjugation. This is having more alpha hydrogen, this is having less alpha hydrogen. So D is the most stable one. D is the most stable one. This one, D. This is B. D, B. D first, then B. It forms more stable carbocation. So this is more reactive. Then B. D, B. Then C. Then A. D, B, C, A means it is option number D. D, B, C, A. After this, which of these will produce the highest yield in Friedel-Crafts alkylation reaction? Now have a look. This is meta-direct. Remember, Friedel-Crafts alkylation or Friedel-Crafts acylation have a limitation. That reaction is having a limitation. What is that limitation? Limitation is simply that meta-directing or what we call deactivating groups, electron withdrawing groups attached to benzene ring do not generally show Friedel-Crafts reaction. That means it will not show. Then after that, if we talk about NH2, if we talk about aniline, during Friedel-Crafts reaction, there is Lewis acid. Say for example this one. It can react with Lewis acid and it can form this one, in which nitrogen will be acquiring a what we call positive charge. Hence it will deactivate the ring. Then further Friedel-Crafts reaction will not take place. Similarly, if we talk about oxygen, I mean say phenol. Phenol can also react with AlCl3. It can also react with AlCl3. That clearly indicates that here OH having a positive charge, that means oxygen is having a positive charge. That means it also does not prefer what we call Friedel-Crafts alkylation, electrophilic substitution. But this can undergo Friedel-Crafts alkylation, Friedel-Crafts reaction, whether it is alkylation or whether it is acylation. It can undergo. It can easily undergo. That means major product of Friedel-Crafts alkylation will be obviously in this. Highest yield will be this one. It will be this one. After this, which of the following reactions will not produce a racemic mixture? Which will not produce a racemic mixture? Have a look. First, your ketone is like this. Your ketone is like this. This on treatment with HCN, that means nucleophilic addition reaction, what will be the product? Product is cyanohydrin, we know this. Positive part, negative part, trick-wise, positive part, negative part, give negative part to positive, positive to negative, and double bond becomes single bond. So it will be like this. When you look towards the product, this is having chiral center. That means if product is having one chiral center, in total there will be two stereoisomers, one this one, plus its enantiomer. That means two enantiomers are formed here in equal proportion, which means racemic mixture is obtained. Racemic mixture is obtained in A. Now, second is B. Have a look. It is CH3, CH3, H, then CH double bond CH2, HCl. Now, what will happen? A very good question. What will happen? It is CH3C, CH3, then it is H, then it is CH with a positive charge, then it is CH3. Cl will be lost over here. Finally, this hydrogen will be shifted in the form of hydride. So 1,2 hydride shift will take place. It will result in the formation of CH3, CH3, here positive charge, then CH2, then CH3. So this is the carbocation. Now, dear students, Cl minus will attack finally to this position and we will obtain a major product like this. So this is the major product of the reaction. But there is no chiral center. No chiral center means there will be no, racemic mixture. There will be no formation of enantiomers at all. But if we look towards reaction number next, HBr, what will happen? Br minus will be lost and we will get CH3, CH2, CH with a positive charge and then CH3. Finally, Br minus will be added to this. Br minus will attack this one and we will get CH3, CH2, CH, CH3 and Br. That means one will be this, another will be its enantiomer. Another will be its enantiomer. That means here racemic mixture is also formed. Here racemic mixture is also formed. In B, there is no racemic mixture. What about D? What about D? Have a look. When you add HCl to this will attack hydrogen and Cl minus will be lost. So we will get first of all a carbocation like this. Carbocation like this. This Cl minus will attack now. This Cl minus will attack now. And we will obtain a structure like this. And if you look towards this is the chiral center. That means one chiral center is there. Its image is also formed. That means its image means its enantiomer will be formed. Its enantiomer will be formed. That means here, this and its enantiomer means racemic mixture. This and its enantiomer means racemic mixture. This and its enantiomer means racemic mixture. But in this one, B1, there will be no racemization at all. So it is B, option B. I hope this point is clear to you. After this, which of the following potential energy diagram represents SN1 reaction? We know, beta, SN1 reaction is a multi-step reaction, generally a two-step process. Generally a two-step process. In first step is formation of carbocation. And that step is slowest step. That means activation energy of transition state will be higher. So in first step, activation energy will be higher. In second step, that reaction is fast. That means option D. That means option D, this one. More activation energy. And in second, there will be less. This is single step process. So this cannot be SN1. It can be SN2. So SN1 can be either this or this. But here, both the steps are taking place. These are both are having similar activation energy. That's not possible. This is having lower activation energy and second is having more activation energy. That means first step is fast, second is slow. That's not possible here. Both the steps are, say, having same rate. No. But what will happen during SN1? First is what we call slowest step and second is fast. That means first is having higher activation energy, second is having lower activation energy. So this is the right answer. After that, increasing order of SN1 reaction in the following compounds is. Increasing order of SN1 reaction in the following compounds is. First compound. Is this visible? Is this visible? Is this visible? Yes, this is visible, but still I will write down. First compound is like this. First compound is, dear students, like this. It's I over here. Second compound is like this. Second compound is like this. It's I over here, but it is OME over here. Third compound is like this. CH3 over here, and then I over here. And in fourth compound, it is like this. What we have to do is, we have to tell increasing rate of SN1 reaction. That means we have to form carbocation. So let me form carbocation in all these. Let me remove iodine. Let me remove iodine. CX bond, because first step of this SN1 reaction is formation of carbocation. So let me remove CI bond, let me remove iodine, let me break CX bond, CI bond, and let me form a carbocation. So carbocations will be formed like this. This carbocation is more stable because of the plus R effect of this. This will, not show plus R on this carbocation, but it will show minus I on this carbocation. Okay. This will show plus H on carbocation. This does not have any atom or any group which shows any inductive hyperconjugation or resonance effect. So I will say this is neutral. So carbocation, in case of carbocation, stability of carbocation or a positive charge species, check first of all plus R, then plus H, then plus I, then neutral, then minus I, then minus H, then finally minus R. Now tell me, first plus R is this one, and this is 4, this is D. So I will write down D first. Okay. Now after that, D is highest stable among these. After that, it is plus H. Plus H is C. Then after that, it is neutral one. That means A. Lastly, it is B. But this is decreasing order. Increasing order will be opposite to this. That means I will write down B, A, C, D. BACD will be the answer. That means D is most reactive. Most reactive is D. After that, it is C. After that, it is A. After that, it's B. Or least reactive is B. Then it's more reactive is A. After that, C is more reactive than A. D is the most reactive. Like that. This will be the answer of the reaction because rate of SN1 is directly proportional to stability of the carbocation. Now, the major product Y in the following reaction. You have to tell me the major product of this reaction. Have a look. Very, very simple reaction. You have to tell me major product. ETONA. This is a strong base and upon heating, it will favor E2 reaction. Just remove leaving group from alpha and hydrogen from beta. When you remove these, you will get a double bond over here. Yes or no? But this is X. This X on treatment with HBr. Addition of HBr takes place according to what we call Morozhnikov's rule. So it will result in the formation of this. First, Br minus will be lost and it will result in the formation of a carbocation over here. And finally, dear students, Br minus will attack on this, and we will get this one. We will get this one. That means ethyl, methyl, methyl, and bromine. That means it is 1, 2, 3, 4. 2 bromo, 2 methyl butane. 1, 2, 3, 4. 2 bromo, 2 methyl butane. That means it's option 1. It's option number 1. Option number 1 is the right answer. Option number 1 is the right answer, dear students. After this, dear students, the major product obtained in the following reaction. Very, very good question. Have a look. Have a look. You are having a structure like this. This is Br. Now, this on treatment with potassium tertiary butoxide. It is potassium tertiary butoxide. It's like this, tertiary butoxide. What is this potassium tertiary butoxide? It is K positive, O negative, then it is C, CH3, CH3, CH3. That means it's a strong base. What will happen now? Alpha position will remove. I mean, say this is simply E2 reaction. So, bromine will be lost from alpha and hydrogen from beta. There are 2 beta positions. But if this hydrogen will be lost, then double bond and double bond comes in conjugation with each other. That means we will form a conjugated, I mean, say alkene like this. This on treatment with ozone. That means ozonolysis. But which ozonolysis? Dimethyl sulfide is there. That means it is reductive ozonolysis. That means just try to break this bond, give double bond oxygen to this, double bond oxygen to this. Break this bond, give double bond oxygen to this, double bond oxygen to this. That means it is CHO, 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 CHO. And after that 1, 2, 3, 4. That means it is CHO, CH2, CH2, CHO. It's option number A. Option number A is the right answer. CHO is this one, then CH2, 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 CHO, yes, then CHO and CHO. Yes, option number A is the right answer. After this, there is assertion reason question. An assertion and a reason given below. Choose the correct answer. Assertion. Vinyl halides do not undergo nucleophilic substitution reaction. Have a look. Vinyl halide is this one. Vinyl halide is this one. It does not undergo nucleophilic substitution because of 2 reasons, because of many reasons, but I will tell you. Number 1, this bond is difficult to break because of partial double bond character. As a result of resonance, it becomes strong. So it is difficult to break. That's why its reactivity is less. Number 1. Number 2, if we want to break this bond, suppose we break this bond, it results in the formation of unstable carbocation. As this is unstable, that's why it will not form, I mean, say this carbocation at all. Now, question says vinyl halides do not undergo nucleophilic substitution easily. That is very, very correct. After that, reason. Even though the intermediate carbocation is stabilized by loosely held pi electrons, no, it will not be stabilized by these pi electrons. Listen carefully, because double bonded carbon having a positive charge, this pi bond will never take part in resonance, as these are formed by p orbitals present in one plane, and this positive charge is present in sp2 hybrid orbital, which is in another plane. So there will be no resonance. This will not be stabilized by pi electrons. That means assertion is correct, but reason is wrong. Assertion is correct statement, but R is a wrong statement. Exactly. R is not correct. R is not correct. Now, after that, it is benzene ring on treatment with HCHO, HCl. Let me tell you, these both will generate actually a carbocation like this. Then methyl chlorination will take place, or chloromethyl group will be added. So it will be CH2Cl. This is known as benzyl chloride. That means it is either A or it is D, benzyl chloride. Benzyl alcohol will not be obtained, benzyl chloride. So A is benzyl chloride. After that, AgCN, it's a covalent compound, and N will attack and N will replace the Cl. So we will get like this, CH2, and then it is NC, isocyanide will be formed. Benzyl isocyanide will be formed. First, benzyl chloride, this one, yes. But this says benzyl cyanide. No, this says benzyl isocyanide. Yes, it is option number A. Option number A is the right answer. After that, the major product of the following reaction is, of this reaction you have to tell me the major product. You have to tell me major product. This is pH. Then pH is attached to CH3. Then there is CHBr. Then it is CH2. Then it is CHBr. Then it is CH2CH3. So it is pH, then CH, CH3, then CHBr, then CH2, then CHBr, and then CH2CH3. Now this on treatment with alcoholic potassium hydroxide, heat, that means it is E2, and alcoholic potassium hydroxide is taken in excess. Now listen carefully, listen carefully. This is alpha, this is beta. Alpha will be lost, beta will be lost from this position, not from this position, because double bond comes in contact with, becomes in conjugation. So extended conjugation will be there. So double bond will be formed over here. First, it will form double bond over here. So it will be like this. CH, then CH3, then it will be a double bond over here. Then it will be CH, single bond CH2, single bond CH, single bond Br, then single bond CH2, and then CH3. Finally, as KOH is taken in excess, let me do another E2 reaction. So now, beta, this is alpha, this is beta, this is also beta, but I will prefer hydrogen to be removed from this one so that pi and pi comes in contact with each other. They becomes in conjugation. So the major product of this reaction will be like this. It is CH, sorry, it is not CH, it is C, because hydrogen has been removed. This is C, CCH3, then double bond CH, single bond CH, double bond CH, single bond CH2, single bond CH3. That means carbon-carbon double bond should be such that there should be ethyl attached to this one, and this carbon-carbon double bond should be such that to which methyl and phenyl are attached. Methyl and phenyl are attached to one double bond. That means these two can be, the products, but after that double bond is in conjugation. Here it's not in conjugation, so it is A1. It's option A. It's option number A. After that, the major product of the following reaction. Major product of the following reaction. That means you have to tell me the major product. Have a look, beta. Have a look. It is OH over here. Then it's like this. First of all, you have to add HCl. Once HCl is added, then what will happen? Then what will happen when HCl is added? As well as AlCl3 is there, it will help in removing of this HCl, this Cl. So what will be the product over here? Product will be like this. It is OH. Then it will be a positive charge over here. Positive charge will be present on this. If I number from the positive charge, say for example 1, 2, 3, 4, and 5, so that reaction takes place, an intramolecular alkylation, Friedel-Crafts alkylation reaction will take place. So it will acquire a positive charge over here. This is 1, 2, 3, 4, 5. 5-membered ring. 5-membered ring will be formed. 5-membered ring will be formed. This is 4. This is 5. Then this is 3. This is 2. Then this is 1. To 1 there is methyl group. There is methyl group. Now to 4 there will be a positive charge. From 5 positive, this hydrogen will be removed, and finally H positive once removed, we will get a 6-membered ring to which OH is attached, and a 5-membered ring over here. 5-membered ring over here. Yes. To this it will be CH3. 5-membered ring to this CH3, and this is 1, 2, 3, 3 and 4, 3 and 4, 1, 2, 3 and 4. Yes. Okay. So it will be like this. It will be simply this one. 1, 2, 3. Option number D will be the right answer. Very simple reaction. After that, the major product of the following reaction. It is simply an E2 reaction. It's simply an E2 reaction. E2 reaction. What will happen? From alpha position, leaving group will be leave. Okay. From this is also beta. This is beta. But this is rich. This is poor. Hoffman is this one, that is ZZF. So ZZF product will be the major product. So double bond should be between carbon and carbon. To one carbon there should be H and CH3, and to another there should be CH3 and this ester group. H and CH3 to one, and to another CH3 and ester group should be present. It should be like this. It should be like this. I hope this point is clear. I hope this point is clear. From alpha, this Cl will be lost. Is this clear? Is this clear? Is this clear? Is this visible? Yes. You can zoom it. This is visible. This is visible. This is visible, dear students. So it will be simply E2 reaction. So remove halogen from alpha position and beta from that position which can form ZZ product. I mean, say from that beta position which is having lesser number of hydrogen. So that means there will be a carbon-carbon double bond, and to this double bond there will be hydrogen CH3, and to this double bonded carbon there will be CH3 and ester. So hydrogen CH3 on one side, CH3 and ester group will be on another side. I hope this point is clear. After that, the major product of the following conversion is major product. You have to tell me the major product. Very, very, very good reaction. CH3O, and then it is benzene ring, phenyl ring. To this it is CH double bond CH, single bond CH3. What you have to do is you have to add HBr. You have to treat it with HBr, but that in excess. First, it will add to this HBr, Br minus will be lost. And we will get a product like this. We will get a product like this. Carbocation will be formed over here because this carbocation is more stable due to resonance. Finally, Br minus will be added to this position, and once Br minus is added to this position, we will get this one. We will get this one first. But as HBr is taken in excess, so HBr upon heating, what will happen now? This bond will be broken because oxygen and carbon bond of this ring is more stronger due to partial double bond character. So H goes to this one and Br goes to this one. So the product of this reaction will be OH over here. That means it's a phenol which is obtained, then CHBr, then CH2, CH3, and finally CH3Br. Is there any option like this? OH, that means phenol. Phenol is this and this, but it is CH which is attached to, say Br attached to benzylic position. That means Br attached to benzylic position means it's option number B. It is option number B. It is option number B. After this, the major product of the following reaction is, have a look. It is this one. It is this one. It is CH3, then it is what we call Br. This on treatment with sodium methoxide and methanol. It's a strong base. What will happen? It will remove this hydrogen from beta position. It's an E2 reaction. It will remove this hydrogen and then it will be alpha beta position from which elimination takes place. So we will get a product like this. So this will be the major product of this reaction. That means option B. Option B is the major product. Option B is the major product. Let me know in the chats, is this clear? Am I clear till now? Am I clear till now, beta? Beta, am I clear till now? Let me know in the chats quickly. Let me know in the chats quickly. Let me know in the chats quickly. Okay, that's great. Now, after this, we have few more questions. 1, 2, 3, 4, and 5. Only 5 questions remain. That means we have completed 95 questions till now. We have solved 95 questions till now. Now, there are 5 questions only now. Come on. Only 5 questions are there, so there will be no break at all. There will be no break at all because there are only 5 questions remaining, my dear lovely students. Come on. Tell me, which of the following upon treatment with tertiary butoxide, sodium tertiary butoxide, followed by addition of bromine water, fails to decolorize the color of bromine. Have a look. What is meant by, if this is treated with tertiary, sodium tertiary butoxide? What is sodium tertiary butoxide? It is a strong base. Now have a look. What will happen? What will happen in first case? What will happen in first case? What will happen in first case? This is alpha, this is beta. As sodium tertiary butoxide, that means TBuONA, this is a strong base, so E2 reaction will take place. But for E2 reaction, there should be hydrogen present at beta position, as there is hydrogen present at beta position, so it will result in the formation of this one. So it will result in the formation of this one. Now, second one is this. Second one is this one. This on treatment will result in the formation of this one, alpha, and this is beta. Then third one, have a look. Have a look. Sodium tertiary butoxide. Sodium tertiary butoxide heat. But this is alpha. There is no beta hydrogen. If there is no beta hydrogen, so it is simply what we call SN2 reaction. So if it is SN2 reaction, the product formed over here will be simply like this. It will be OBUT. I hope this point is clear. Now, if you talk about last one, if you talk about this last structure, this is Br, this is alpha, this is beta. Now that means here once again there will be E2 reaction. So here what will be the product? Product will be like this. Now tell me, dear students, this is on treatment with tertiary butoxide, followed by addition of bromine, followed by addition of bromine water. That means bromine water. Bromine water will add across carbon-carbon double bond. That means it will give, say, test for unsaturation, because bromine color will be decolorized. That means in this case, bromine will be decolorized. Similarly, as there is double bond, so bromine water test is positive. That means bromine will be decolorized. Similarly here, bromine test is positive. Bromine water on treatment with this, as this is having double bond, bromine will get decolorized. But here will be no bromine water. Will be no bromine water test positive. Here the test is negative. Why? Because there is no double bond. No double bond means there will be no decolorization of bromine. So question says, which of the following upon treatment with tertiary butoxide, sodium tertiary butoxide, followed by addition of bromine water, fails to decolorize? This one. This one means this is option C. It will fail to decolorize. It will not decolorize at all. It fails to decolorize bromine. Yes or no? Because bromine color will not be decolorized in this case, because decolorization of bromine means test for unsaturation, but there is no unsaturation at all. There is no double bond at all. Now have a look. Question says you are having C6H5, then it is like this, C6H5. Here it is bromine, here it is hydrogen. This on treatment with tertiary butoxide, but which one? Potassium tertiary butoxide and heat. That means it's a strong, what we call base E2 reaction. This is alpha, this is beta. Remove hydrogen, this halogen from beta and from alpha, and what we call hydrogen from beta. Remove halogen from alpha position and remove hydrogen from beta position. So you will get like this, C double bond C. To one C double bond C, there is hydrogen in phenyl, another hydrogen in phenyl. That means azobenzene will be the product. That means it will be this one, C6H5, C6H5. Oh, it's like this. So this will be the product. This will be the product of the reaction. I hope this point is clear. I hope this point is clear. After this, the major product of the following reaction is, major product of the following reaction is, and reaction is like this: C6H5CH2, then it is CCH3, then Br, then CH2CH3. This on treatment with C2H5ONA and C2H5OH. It's a strong base. It's a strong base. Now, what will happen? E2 reaction will take place. E2 reaction means from this position, bromine will be lost from alpha, and there will be beta, which will be, hydrogen will be lost from beta. But if we remove hydrogen from this one, what is C6H5? Let me show you. C6H5 means phenyl group. It is this one. It is phenyl. If you remove beta hydrogen from this and alpha from this, there will be a double bond, and this double bond and ring are in conjugation, extended conjugation will be there. So the product will be simply this phenyl. Major product will be phenyl, means C6H5, then CH, then double bond C, CH3, then CH2, CH3. I mean to say, carbon-carbon double bond should be such that to one carbon, double bonded carbon, there is hydrogen in C6H5. To another, there is methyl and ethyl. Have a look. This is carbon-carbon double bond. To one, carbon double bonded carbon, hydrogen and phenyl. To another, methyl and ethyl. So it is this one. It is this one. I hope this point is clear. Then we have another question. Structure of the major product formed in the following reaction is very, very simple. Very, very, very simple reaction. Very, very simple reaction. It is like this. NaCN means in DMF, dimethyl formamide. That means it is simply SN2 reaction, because this is a strong nucleophile and this is polar aprotic solvent. Polar aprotic solvent favor what we call SN2 reaction. But what is SN2 reaction? Nucleophilic substitution reaction. This is haloarine. It is difficult to cleave this bond. So it is difficult to replace this by cyanide by nucleophile. But it will simply attack this and this will leave. That means we will get simply this product. Here it will be CN as the major product and I. So I will remain as such, but here it will be CN. That means it is option number D. It is option number D. It is option number D, my dear lovely students. After this, there is a last question of this session, that is, what is DDT among the following? What is DDT? Dichloro, diphenyl, trichloroethane. And that is a non-biodegradable, remember, pollutant. It's a non-biodegradable. And remember, DDT is what we call an insecticide. It is very effective against Anopheles mosquitoes, which causes malaria, or it's very effective against lice that may cause typhus. And remember, it's a fat-soluble compound and it is non-biodegradable. So this is all about for today's session. So my dear lovely students, my dear lovely doctors, thank you and God bless you all. Now, it's part 2. Will be another 100 questions, and that part 2 will be on Tuesday at most probably 3 p.m. once again. But before I end this session, once again, I would want to tell you that I will be sharing this whole PDF of this session once again on my Telegram channel, and that Telegram channel is a new one, so you have to search it on Google, and that Telegram channel is t.me/KKSirChemistry. KK Chemistry class. But my dear lovely students, once again, thank you very much to all of you. And before I end this stream, I would want you all guys to comment after I end this session. Comment that how much you like this session and where from you were watching this session. So anyways, thank you and God bless you all. May you get success in your NEET 2026 on 21st of June. Take care. Bye-bye and love you all and God bless you. God bless you and take care all.